Good morning, ladies and gentlemen. I'm Angel Mary from AWS User Group Community. This is track 2. I will be your host for this track. We have one more technical track happening in parallel. Link to track 1 is given below in the description. Let me walk through the today's agenda in track 2. We have 6 technical sessions by industry leaders. We also have a few exciting games and quiz competition. First, we have Yogesh Sharma for the topic Intelligent Serverless and Scalable Real-Time Data Pipeline using Kinesis, Fargate, and CloudFormation. The second, we have Tushar Gupta on Secure Cloud Governance with AWS Landing Zone. Third, we have a talk on Going Viral with AWS Artificial Intelligence Machine Learning Services by Mike Chambers. Then we have a short lunch break for 30 minutes. Thereafter, we will be conducting a quiz competition for you all. In the afternoon session, we have Mayank Raj on serverless cron with second level schedule and conditional flow. For the fifth talk, we have Vijay Nirmala for Unicorn, leverage and accelerate CI/CD for databases using AWS native tools. For the final session, we have a talk on linear TV broadcast playout on-demand disaster recovery by Vijay Sagar Vinnakota and Arpit Malani. At the end of each session, we request you to send us the feedback. Use our Lanyard application for rating our speakers and providing feedbacks. Link is given below in the description. You can post your doubts, questions in the YouTube comment box. Our team is standby to answer them. Don't forget to share in the social media. Use the hashtags ACD India, AWS UG India. We have an exciting prize for the best tweets and shares. Let me introduce our first speaker for today's technical session, Yogesh Sharma from TCS. He has 10 years of experience and working in TCS as cloud architect. He is passionate about cloud, machine learning, and DevOps. He started his journey with cloud in 2015 and since then helped giant customers across different domains in their cloud and digital journey. Yogesh will be talking about intelligent serverless and scalable real-time data pipeline using Kinesis, Fargate, and CloudFormation. Welcome Yogesh to AWS Community Day. Over to you. You are
Thank
live
you.
now.
Thank you. Okay. Hi all. This is Yogesh Sharma. I hope you all are doing fine, staying healthy and safe. I welcome all of you in the AWS Community Day India event 2020. So without wasting time, let's get started. For today's, my topic is intelligent serverless and scalable real-time data pipeline using Kinesis, Fargate, and CloudFormation. Before starting the session, let me quickly introduce myself. I'm Yogesh Sharma. I'm currently working in Tata Consultancy Service and working as a cloud architect. I have overall of 10 plus years of experience. And since last 5 years, I'm working in the cloud, DevOps, ML area. I'm an active member of the AWS community. Currently, I'm holding 3 AWS certifications. I'm also a technical speaker and blogger, and currently running the multicloudwarrior.com. And you can connect me over the LinkedIn for further updates. Okay, so let's quickly cover the agenda that we are going to discuss today. First, I will start with the demo architecture that we are going to create a live demo at the second half of our session. Then we will first discuss about the serverless, what is serverless, what are their benefits, why industry is moving towards the serverless. Then if we need to play with the real-time data streaming, how we can use the AWS resources, AWS services like Kinesis, and also if we need to deploy the real-time data streaming application on container, then how we can adopt the serverless Fargate container task. Then we will cover the demo, and in the end I'll just share some new trends, what is happening inside the container world with respect to the AWS. Okay, so moving ahead, this is basically the demo architecture that we are going to build at the second half of our session. So don't worry about all these services that I have shown here. We will create this architecture and I'll show you and a little demo in the end. Okay, so before moving ahead, first we will talk about what is serverless. So when we talk about the serverless, there are four key characteristics with respect to the serverless. The first one obviously is like you don't need to worry about the provisioning, management, orchestration. Like we client just need to worry about the business logic. Everything will be taken care of by the AWS. Second would be pay for value. So whatever we are using, we are going to charge for that. For example, if we are using the Kinesis for real-time data streaming, AWS is gonna charge us as long as like we are ingesting the messages or records into the data stream and stream is holding that particular data. Otherwise, they are not going to charge us anything. Then the automatic scaling, security and reliability and availability are also the out-of-box solution that AWS provide with respect to its serverless services. Now quickly have a look over the AWS serverless portfolio, what AWS provides with respect to the serverless services. So across almost every domain, AWS has the serverless fully managed services with respect to the compute, database, storage, messaging, analytics. So take an example of the compute. On the left hand side, we can see the traditional approach where we are using the virtual machines and the on-premises servers. Then as we gradually move towards the right hand side, we can see industry has adopted the compute machines. Then comes the Fargate. We are using the Lambda, which also known as function as a service. If we talk about the storage, AWS S3 is a perfect example of the serverless storage. So I think every client, every user, if they are using any of the AWS services, they are probably using the S3 anyhow. So perfect example for the serverless storage service. For database also, they provide Aurora Serverless, DynamoDB service that are basically the fully managed serverless services provided by AWS. So why industry is moving towards the serverless and why serverless has greatest agility with the least effort? It basically allows customers to focus only on the business logic and API that they are going to build, and all the heavy lifting work will be taken care by the AWS, like physical infrastructure, compute, how they are going to store, how they are going to orchestrate, and messaging buffer. All these things will be taken care by the AWS. Now moving towards the session, or basically the demo that we're working towards. So the first part of that demo is the streaming solution. So what is basically the streaming data? So typical characteristics of the streaming data is like it is a continuous stream of data of high volume, ordered incremental stream of data with low latency. There are various streaming use cases across our industry that we can see in day-to-day life, like the mobile apps. If someone is playing game, the real-time in-live gaming scorecard, web click stream, application log is a perfect example. So nowadays, if our application is generating any amount of logs in our web server, we can stream it out and channelize it to using the real-time data solutions and store it somewhere else and perform the analytics on top of that. IoT sensor smart buildings are also the perfect example for this streaming use case. But when we talk about the data streaming, it's not quite easy to set up. There are various challenges involved with respect to the data streaming, like it is difficult to set up, tricky to scale, not easy to gain the high availability, and it is also expensive to maintain. Here comes the AWS Kinesis service that basically solves almost every challenge that we have listed down over here. So what is primarily is the AWS Kinesis stream? It is basically the high throughput, low latency service to handle the real-time streaming data over the distributed systems. And AWS provides 4 different flavors when we talk about specifically to the data stream. There is also a Kinesis video stream that we are not going to discuss. So with respect to the data stream, 4 major services or flavors. The first one would be the Kinesis data stream, regular Kinesis data stream, where it will be used for the capture and storing the data streams. Second flavor would be the Kinesis data analytics, where it can act upon the incoming data from the Kinesis data stream and analyze the data on the fly. We don't need to store any the data to any destination. On the fly, we can perform some analytics. Quite cool service. Third one would be Amazon Kinesis Data Firos. It basically channelizes the real-time streaming data coming out of the Kinesis data stream and store and provides a destination like a facility where we can store the incoming data onto a specific destinations. We'll discuss about that in next slide. The fourth one would be Amazon managed streaming for Kafka. So if some clients are using the Kafka, then they can opt for this particular service. So for real-time data streaming architecture mainly comprises of 5 stages, starting with the source, like which particular source is generating the data. It could be clickstream, it could be web server logs, it could be IoT sensor. Then to ingest the data, we need something called as producer, famously called as Kinesis producer. It could be a Amazon Kinesis agent that AWS provides. We can install it in the EC2 compute machine, and it will basically watch a particular log file, batch it, aggregate it, and stream it to the Kinesis data stream. Second option to create the Kinesis producer is using the Kinesis producer library. We are going to use this for our demo. If someone wants to build a custom-made solution, we can use the Kinesis producer library. Third one would be AWS provides different SDK, as we all know, in different languages. We can probably use that also. Then Kinesis data stream basically store the data up to a limit, like maximum 7 number of days. Then after the data has been ingested into the Kinesis data stream, we need to process that data. For that, we can choose Kinesis data Firos to channelize the data and store it to the popularly called 4 destination: S3, Redshift, Elasticsearch, and Splunk. Or we can have for Kinesis data analytics, or we can create a custom built solution using the Kinesis consumer library. We are going to use, I have developed my demo regarding this using this particular library. Now, how Kinesis stores the data? It basically stores the data in the form of shards. So whenever we are creating the Kinesis data stream, we need to define how many shards we need. Though, and at the later point of time, also we can perform few operations like split shard, merge shard to divide the shards and to increase the unit of parallelism. Otherwise, we need to define at the start. And few properties would be like data retention by default would be 24 hours. Otherwise, and the maximum would be the 7 days. And interesting properties like it is immutable. Data would be immutable. We can't delete the data. It will only get expired after, let's say, maximum of the 7 days. Now, whenever we are designing primarily the consumer application, we need to think of 2 types of consumer: standard consumer and enhanced fan-out consumer. Standard consumer is where we are going to write our consumer application, and it will call suppose if you are using the KCL, it will call the get records API, and there are few limits associated with the standard consumer, like 2 MB per second per shard across all the consumer application. So every consumer application need to share this egress bandwidth. And with respect to the get records, it would be like 5 transactions per second per shard. On the other hand, if we talk about the enhanced fan out, that is basically the advanced way to create the consumer. So here, every consumer gets a dedicated 2 MB per second egress per shard. It is basically kind of push-based methodology, unlike the pull-based with respect to the standard consumer. We will basically subscribe to each shard and get a 2 MB per second egress dedicatedly for every consumer application. Now, how are we going to run our Kinesis producer and consumer application? So we are going to run it as a Fargate container, because if we think about the capabilities of the modern application architecture, the application should be secure, resilient enough, elastic. It should be highly scalable, like it should act on the incoming data or whatever the metrics, and it should perform the auto scale operations. It should be modularized, automated, and interoperable. So when we think of all these capabilities, we think of the term container, because container provides various benefits. Like the first one would be the portability across different solution, security, improved security because it has the isolated applications from the host and also among each other, faster startup and easier scaling, and also better resource utilization. Unlike VM, we can specify specific CPU and memory parameters over there for every container. It could be less or more for different container as per our requirement. Now Amazon provide different container services across different domain. Like for the registry, it provide Elastic Container Registry. We can think of it on the similar front of Docker Hub, where we are going to store the container images, so that the container task these images to launch the container task. Then for the orchestration, we have the ECS, EKS, and for compute part, we can use the Fargate and EC2. Now the ECS service provides various benefits. Like it is basically having the global footprint. It provides user the capability how they can run the container onto the AWS platform, how they can interact with different services like the VPC for the networking part, EBS or EFS for the storage part, auto scaling for the scaling operation. We can connect it with the CloudWatch basically for the logging and monitoring solution, and also we can create a service. We can integrate it with the load balancer so that we doesn't need to directly communicate with the producer task. We can communicate with the load balancer, and behind the scene it will communicate with the producer task to ingest the data. So this is the typical architecture example that I was talking about. Like we have the load balancer in front, and inside the EC2 instances, we have here running our container task, having the ECS agent running on every EC2 instances to communicate with the ECS service, ECR service, and other related services. So we just need to focus on the business logic that we are going to uh, define inside the container, and everything else would be taken care of by the ECS. Now, if we that ECS normal standard ECS was one set of service that ECS provide. The second one would be the Fargate. So if we think of in terms of if we need a seamless scaling, and if we don't need to worry about the whole management of infrastructure and orchestration, then we can think of the term Fargate. So as Fargate provides various benefits, like we don't need to manage any cluster. Everything is handled at the container level. It scales seamlessly on demand. Benefits are cost reduction up to 50%, and latest AWS has provided the Fargate Spot, just like we have the Spot instances for the EC2. We can associate the Fargate container with various different services like secret management, private link support. It has the cloud map integration support. We can do the tagging and cost allocation with respect to the Fargate containers. But how does actually Fargate work? So we need to define a few things before we actually say, okay, our Fargate container task is actually running. So we need to think of whenever we are creating the container task, we need to think of the task definition or the container definition. So task definition is something where we need to define the image, whatever we are running, CPU and memory requirements. So basically inside the task definition, we need to define the container definition, and container definition holds all this information. And service is something, if we need to maintain the multiple running copies of the container, we need to create the service. And also if we need the ALB, we need to create the service to integrate with the application load balancer.
Sorry to interrupt. Could you please go on somewhat slow?
Sorry?
Could you please go on in somewhat slow?
Sorry, I didn't get you.
Can you hear me now?
Yeah.
Could you please go on somewhat slow? It is.
Okay.
Thank you.
Yeah, so advantages would be that Fargate provides is we can bring our own Docker image, and we can put that particular image into the Elastic Container Registry, and we can use that. Also, we can run all the Fargate containers inside the VPC, and we can invoke whenever it is required, or we can integrate it with the auto scaling policy, so that as per the metrics, be it the CPU utilization or the incoming traffic, it will act on that. Also, we can integrate the Fargate container task with the CloudWatch for logging and monitoring purpose, and we can also define the volume mount, basically the ephemeral storage space for volume mounting thing with respect to the Fargate task. Now, as we are gradually moving towards the demo part, so I have created everything using the CloudFormation, basically for the infrastructure as a cloud. I have created a few YML script with respect to the CloudFormation to provision and to launch all the services with respect to the Fargate, like the ECR, Kinesis Firehose, S3, Elastic containers, and the task definition, and also the CloudWatch dashboard. Okay, so I think we can move towards the demo part. Yeah. So to save the time, I have just executed two CloudFormation template just before an hour of our live event. So this is the first CloudFormation stack that I have executed. And it is basically, if you go under the output section, it is basically used to create the container repository for both consumer and producer. Then I have created the Kinesis stream, Kinesis Firehose inside the same CloudFormation template. And also in the end, I have created a cold build project that will basically use to deploy the Docker images inside the ECR. So if I show you, these are the Elastic Container Repository created by that CloudFormation template. So if I go inside the producer ECR, you can see we have the latest Docker image with respect to the producer, and I have created the Kinesis data Firehose and Kinesis data stream, and Kinesis data Firehose is basically associated with the S3 bucket. This one. So if I quickly show you the CloudFormation template for the that I just executed. So initially, I am creating the ECR repository for both the producer and consumer. Then I am creating Kinesis data stream, followed by the Kinesis data Firehose. And inside that, I have provided the S3 destination as a S3 bucket. Created the S3 bucket also. Created few roles that I am going to use for the cold build project. So if I see the cold build Docker project, it is basically used to create the container ECR images using the code that I have stored in my GitHub repo. So it will use the Docker file, create the Docker image, and push it into the respective ECR. And we are getting these fields in the output section. Now moving towards the second CloudFormation stack. So it is basically a cross-stacked reference. So I have used the Kinesis data stream and other properties that we have created in the first CloudFormation stack, and I've used it in the second CloudFormation stack. So here I am, if I quickly show you. Here I am creating first accepting few parameters like what would be the maximum producer, maximum consumer task that we need, and also the container scaling target. So for the demo purpose, I have moved it to the 20. So whenever the CPU utilization is above 20%, the auto scaling policy will get triggered and will launch the new containers on the fly. Okay, quick before going deep into the CloudFormation stack, I will just show you the dashboard that we have created, because I need to generate some amount of data to perform the auto scaling also. So this is the dashboard for the producer, consumer, and for the Kinesis data stream. Currently, the active producer and active consumers are 1. So what I'll quickly do is I will run a program using the Locust. Locust is a load performance tool. And I will copy. We will basically ingest the data through the ALB, and because ALB is running in front of the producer task. Now if I come refresh this, so in Locust it will create this many amount of simultaneous user that we are giving, and all these users are start creating the request onto our host, that is ALB, so that it will create the humongous amount of data requests, so that our producer and consumer task will get auto scaled. Okay, now coming back to the CloudFormation code again. Yeah, so initially we are creating the network related component with respect to the VPC, public subnet, 2 set of public subnet, 2 private subnet, 1 for consumer, 1 for producer application. Then I'm creating the internet gateway, net gateway, routes. Then from this step, I'm creating the ECS cluster, ECS task execution role that is basically needed to interact with the ECR and other destinations. Task log group. Then we are defining the ECS task producer definition. So inside that we can see memory and CPU utilization, or memory CPU parameter that I have defined. And inside the task definition, we have defined the container definition, and container definition will basically create the image. So it is for the producer. So I have provided the producer image, and similarly the CPU and memory parameter. I've exposed the port 8080 also because it needs to connect with the ALB. Then the logging and monitoring information, basically the CloudWatch log groups. Also, I have provided 2 environment variable that I am using inside the Docker images, basically to create the Docker images. Then after we have defined the task definition, we need to think of something ECS service producer that I discussed in my slides. Now this particular service is basically associated with the task definition and also with the load balancer. If you see there is a load balancer tag, and it has been associated with the specific target group that I have defined inside in the same CloudFormation template, and container port, it is basically hitting on the container port 8080. It is associated with the same task definition, producer definition. Then I've defined the ECS auto scaling target producer, basically the ECS auto scaling policy. That is, if CPU utilization is above 20%, it will trigger the auto scaling part. Similarly, for the consumer also, we have defined the consumer task definition, and inside that we have the container definition, where we have the consumer image running, memory and CPU parameter, and ECS consumer service. We don't need any ALB inside the ECS service consumer, because ALB will be associated only with respect to the producer task, not with the consumer task. There is no sense in that. Now moving towards, similarly, I have defined the auto scaling policy for the consumer. Here I have created the ALB and its respective target group and associated it with the producer service. Now in the end, I have created the CloudWatch dashboard. This dashboard basically provides different widgets for the metrics like the active producer, consumer, Kinesis, and the CPU utilization of the consumer and producer tasks. The same thing that we observed over here. Now if I see, because we have ingested some amount of data, if I see over here in the CloudWatch logs, because I generated some data with respect to the, so we are getting the data that we are generating from the producer, and this is basically the consumer logs. We are getting that data. If I check the S3 bucket also, because this particular S3 bucket is been associated with the Kinesis Firehose. If I go inside this, okay, I will quickly generate some more data. Where I'm basically posting the data, some sample data onto the ALB. So ALB will associate it with the producers, and the producer will push the data into the Kinesis data stream, and consumer will act and start consuming those data. Now moving on to the CloudWatch dashboard. If you can see, yeah, active producer and consumer has been increased to the 3, because we have basically pushed humongous amount of requests onto the ALB. If I go inside the producer ECS cluster, producer service, the task, it has been increased, you can see. And this is the producer service. It is associated with the load balancer target group. Also under the auto scaling, you can see maximum number of tasks is 20, and scaling policy is acting on the 20% for the average CPU utilization. Under the events tab, we can see there are various what is happening with respect to the Fargate task, whether it is launching new task or draining out the old task or not. Similarly, we have the consumer service also. There is no ALB with respect with the consumer service. If I go inside the task, we can see currently the 7 tasks are running. Similarly, the auto scaling policy for the ECS is also defined here. Maximum task is 10. Similarly, the average CPU utilization 20. This is basically the scaling policy. And under the events, we can see, so the as of now it has been reached to the steady state, but the following tasks are like, okay, it basically started 4 new tasks on the basis of the monitor with respect to the auto scaling policy. So this was the coming back to the slide. So this was the main idea that I want to showcase in my demo. Is we basically generated the humongous amount of data onto the application load balancer. We are running the Kinesis application, producer application onto the producer task, and I'm running the Kinesis consumer application on the Kinesis consumer task. And Kinesis producer is basically ingesting that data into the Kinesis data stream, which are being consumed by the Kinesis consumer application, running in a separate Fargate Fargate service, and each and everything like this producer Kinesis producer Fargate task and Kinesis consumer Fargate task and Kinesis data stream are associated with the CloudWatch, and we are basically on the basis of a metric we are doing the auto scaling for both Kinesis producer task and Kinesis consumer task. So, so moving towards the end, there are few new trends that AWS has introduced for the Elastic Container Services. Like AWS recently announced the AWS Copilot, a new CLI tool to deploy and operate containers in AWS. Also, now we can monitor the Prometheus metrics in CloudWatch for container environment, and also Amazon EKS has introduced like we can use the Fargate orchestration in Amazon EKS, and also we can use the Fargate Spot instances with respect to the Elastic Container Services. So yeah, that's come to the end of the session and demo. That was all. I hope you have enjoyed the session. Now I think we can continue for the Q&A part. Thank you all.
Thank you, Yogesh. Now let's have a quick look whether we have any questions from the audience. And the first one is from Shubharata Dasgupta. Could you please give a quick comparison between Kafka and Kinesis?
Okay, Kafka and Kinesis. So Kinesis is basically a fully managed services that AWS provides. Kafka is a bit of open source. So if you think like what Kinesis provides is a good thing is like the checkpointing stuff. So suppose if we have written few of the consumer application, and if some consumer application fails up, then how the new consumer application that we will create, it will determine how to resume the operation from that particular checkpoint. What Kinesis provides, we can create the application using the Kinesis consumer library in a fashion like it will store the checkpointing in DynamoDB. So whenever the new consumer application will come up, it will pick up that particular sequence point and start resuming the operation from that particular point. Kafka is also being used for the real-time data operation, but we need to manage everything like how we are defining it will do the scaling operation with respect to just like the shard, they have the partition, we are going to manage all those partitions. But what Kinesis provides is like a fully managed service. So I hope that answers that question.
We have one more question. Can we do some intermediate data processing between the producer and consumer? Is that native to Kinesis or should we use some additional service?
Okay, so with respect to the basically when we say consumer, it is streaming processing only. We can consume the data and we can process that particular stream. Though if we need if we need to perform some kind of analytics on the fly, we can use the Kinesis data analytics service that will do that operation. But if we are fine, like if we are consuming the stream and then we are doing the processing, that also is possible. So in one of my project with a client, we did that only, like we are consuming the stream and then we are processing that, and after that we are just sending it to another stream so that another few other servers can utilize those streams.
Okay, we have one more question. We can pass data from Kinesis data stream to Kinesis and data analytics for further processing, and then use Firehouse to upload to S3 bucket.
Yeah. So Is this a question? What?
Sorry. Yes, it's a question.
What was the question?
We will show you once again. Please hold on. He's asking. Okay, we will pass on to next question.
Okay.
Can one position Kinesis as an ETL tool in enterprise scenario? How realistic is it from a perspective?
Okay, so with respect to the cost, it would always be tricky because we need to think of various factors with respect to the enterprise for which we are building and also with respect to the resources. So suppose if they are using the Kafka since long, then we can opt for that. Otherwise, I have seen because in one of our clients, they were using the Kinesis for the ETL. So what actually was the overall approach was like they are ingesting the data from a CDC source system to the Kinesis, and then after the Kinesis, we are using the Apache AWS Glue to perform the ETL operation in an AMR cluster, and then at the destination side, we are storing that into the Aurora DB. So that is very much possible, but the cost factor always remains like we need to think of various other related factors before deciding the cost and before deciding the technology. Yeah.
Thank you, Yogesh. We have some more questions from our community,
Okay.
and we would like to know about your favorite service in AWS and why this.
Okay, so my favorite service is basically the AWS Lambda because it is the perfect service. I mean, we don't need to worry about anything, any server, nothing. We just need to know any programming language, be it what AWS Lambda supports, or we can create our own framework and we can use that. The beauty is like it's just an we can think of it as an IDE only, but behind the scene it is running on heavily server that we don't need to worry about, and it is beautifully integrated with every other services. We can perform a cron branch kind of operation. We can perform like synchronous operation, asynchronous operation, event based operation. We can integrate with Alexa. I've created one app. It works seamlessly. So yeah, I love AWS Lambda.
We have one more question. We would like to know the toughest problem faced and when architecting on AWS and how you solved it.
Okay, so toughest problem faced initially was because it was at the time when like the private link and the VPC endpoint services just launched. So the problem was okay, we need to create a service with with the following components like ALB and the EC2 instances. And we initially we designed it like as a internet faced. Then the client said, okay, but I need a very high security. It should be like uh, like the private based access onto the EALB also. And I think at that particular time only AWS launches few of the VPC endpoints like VPC interface endpoint services. So initially we were struggling, but gradually like we read about it using the AWS blogs, how we can utilize the power of VPC endpoint services so that we can create a private link connection and we can restrict that particular service like to a private boundary, unlike the like exposing onto the internet. So that was kind of a great find, and it was a great, I mean, it was fun to solve that particular problem.
Okay, thank you. And we have one more question. As an AWS professional, how does your day look like? And we would like to know your day-to-day activities.
Okay, so day-to-day activities would be like to first is like okay to provide the seamless integration of various services to the user, basically to our client. And currently, like I am working on a project where we need to provide the service supports to the different users inside our firm. So we need to take care of, like, okay, whether are they facing any issues, and also we need to identify various new services that they might use, so how we can basically perform all the compliance action on those services to make it readily available for our users. And besides that, office work, like the normal reading work, normal blogging work for the AWS, that is also something that I look up for.
Okay, thank you, Yogesh. We have two more questions. Why should you use Fargate over Lambda?
Yeah, okay. Yeah, that's nice question. Actually, when we are building this solution for one of the client, we also think of a Lambda as a first. But what happens, we have few challenges with Lambda, like the execution timeout, and like also it is I mean, if we need to build a enterprise level of application, it should be, I mean, we need to think of something that should be a continuous running thing. So in our case, it was a continuous running job, and we need to create multiple consumer application that should have an in fan out kind of structure. So that is why we use the Fargate. Because, and there was another reason also, because initially, before moving on to the Fargate, client were running that particular application onto their on-premise system in a Docker platform. So it was easy to basically just customize few of the stuff in the images, and because of the interoperability feature of the Docker container, it was easy, like, to move into the Fargate environment.
Okay, thank you, Yogesh. One more question for you. Does Kinesis Data Analytics come with different license or it is the same?
It's not a license, we would say. When we talk in terms of AWS, everything is related with the cost. So yeah, so what happens if we have created one Kinesis data stream? If we need to use the Kinesis data analytics services, we just need to create it, the Kinesis data analytics service. We need to bind it with the respective Kinesis data stream, and then inside the Kinesis data analytics, we need to provide the logic that what we are going to build. Are we going to filter anything? Are we going to provide any advanced SQL operation kind of stuff? So the cost is associated with the logic, or with the task that we are going to assign to the AWS Kinesis Analytics service.
Okay, we have one more question for you. What is the first AWS service that you have used?
First AWS service was 5 years back. So I think first AWS service was EC2. EC2 or S3, I don't remember exactly, but yeah, it was, I think it was EC2.
Thank you, Yogesh, for the wonderful insight. I hope all of you enjoyed the session as well. If there is any additional questions from the attendees, Yogesh, we will pass it to you.
Yeah, sure,
Please,
sure, definitely.
please log into YouTube as well. Okay, you can directly comment there as well. Thank you.
Sure, sure, sure. Thank you, guys, and looking forward to the exciting event. We have a great speaker lined up. So yeah, thank you.
Alright, don't forget to share your feedbacks via Lanyard. Let's dive into our second technical session for today. Let me introduce Tushar Gupta from SoftOne. Tushar Gupta is specialized in cloud migration and strategy. He has consulted customers across the globe, helping them in their business IT alignment to realize true benefits of cloud. Tushar will be talking about secure cloud governance with AWS Landing Zone. Welcome, Tushar, to AWS Community Day. Over.
Thank you. Thank you, Angel. And I welcome you all. Uh, okay, let me share my screen first. Okay. Thank you. Thanks, everyone, for taking out time for this beautiful event, AWS Community Day India. Okay, and I welcome you all, and I hope everyone is keeping well in this pandemic situation. Okay, so without wasting time, so let's actually start the session. Okay, I hope everyone is able to see my screen. Okay, so today we are going to discuss about secure cloud governance using Landing Zone. Okay, and as Angel mentioned that I'm working as a senior cloud consultant for APAC region with Software One. Okay, before we actually start the session, let's give me a brief introduction about myself. Okay, so this is me. I have got close to 10 plus years of experience across enterprise data center and cloud technologies. And my day-to-day role is as a working as a consultant for customers, and I'm more specialized in the cloud migration and hybrid cloud architectures to onboard customers to AWS Cloud. In terms of certifications, I've got three AWS certifications. I'm AWS certified advanced networking specialty, and I'm also certified as a solution architect, both professional and associate. So you can connect with me on LinkedIn, okay, and we can actually have more detailed, insightful sessions as well in the future. Okay, so let's start off the session. Okay, so let's talk about of the first, the typical enterprise situation. Okay, where the business uh, units or the line of business expects the central IT team for infrastructure, whether to provision a new service or they want to launch a new service into the market. They put all their infrastructure requests to the central IT team, and what central IT team does that they provision the infrastructure and governance and put governance and service management for that. Okay, so they take a lot of time. They take their suite, all their processes and time in order to provision the infrastructure for the service requested by line of business, uh, to provision the infrastructure for that. So with that, what actually the outcome is that we have a high lead time. Okay, normally central IT team takes from days to weeks to actually provision all the infrastructure which line of business expects to deliver a particular service into the market. Okay, central IT team also has to undergo uh, process heavy service management to provision all the infrastructure and manage all the IT services under that. Okay, and they face a lot of governance and compliance issues as well. Okay, so they don't have any standard, you can say, policies or frameworks, so that they can have a standardized governance and compliance across infrastructure which is provision for the business. Okay, so with that, it comes as a fight or a trade-off between agility and control, where the line of business, my line of business, expects agility from central IT team for innovation and faster time to market. However, the central IT team expects that they need control to protect their business as well. Okay, so the issue, there's a you can say a fight between the line of business and central IT for agility and control. So the biggest challenge which enterprises are facing currently right now is to how to achieve a strong business and IT alignment. So with that, there's an opportunity to achieve both agility and control. And now we are going to see that, okay, so what are those things which we expect from both IT and business to have to achieve agility and control. Okay. So as this figure says that from the central IT team, business expects standardized templates, policies, and best practices. Okay, and which we actually using that standard templates, policies, they can provision the infrastructure and fulfill all the business requirements in a faster way. Okay, with that, a line of business also expects that they need something as a centralized dashboard, something for governance and control on the provision infrastructure. Okay, and central auto team also requires to automate their service management for the provision infrastructure so that they can manage the infrastructure in the later way. So all these things actually are the key requirements as of now to both achieve agility and control. And with that, what we can expect, that we can expect the lead time reduction, a huge reduction lead time from days to weeks to minutes. Okay, we expect a service catalog for landscape management, and also central IT team expects to have a automated service management in place. Let's talk about now cloud governance. So we'll discuss in this particular section that if organization moves to the cloud and scales their infrastructure in the cloud, what are the key drivers of the cloud governance they should look at? Okay, and what are the challenges which normally enterprises are currently facing? Okay, so let's start with that. First, let's discuss about governance at AWS. Okay, so since if we are all aware of the perspectives of AWS Cloud Adoption Framework, so these are the 6 perspectives which AWS expects us to see while migrating to the cloud. So governance is one of the very important perspective of that of cloud adoption framework provided by AWS. So AWS focus from the governance point of view and with their cloud adoption framework is always to maintain speed and agility. So the AWS has built a lot of services and solution to maintain speed and agility in the cloud. Governance, as I mentioned, is a perspective, is not a project altogether, it's not a separate project altogether. And all these perspectives require collaboration and a tight integration between that to leverage all the benefits of the cloud. So let's talk about some of the key drivers for cloud governance. Okay, so the key driver for cloud governance is that with cloud governance, my enterprise can expect standardization. Okay, so I need standardization templates or I need standard policies which I can use across my multi-account structure or multiple accounts or multiple business units if I'm running AWS for my entire infrastructure estate. Okay, my enterprise also expects, apart from standardization, is the most important part is security. Okay, so enterprise expect a secure and compliant infrastructure for data protection and security audit purpose. Okay, so if any enterprise is running any compliance related regulation, okay, so they need to implement all those policies to have the secure and compliant infrastructure so that their audit goes smooth. Okay, IT team also expects from the cloud governance to have operational efficiency. So they need something to have quick infrastructure provisioning and automated service management to run their business workloads in the cloud. So that key drivers of cloud governance, let's talk about some of the common governance challenges which enterprises are currently facing when they scale up in the cloud. These are the 4, you can say, the key common governance challenges which enterprise face when they go to the cloud. So first is control and visibility. Okay, so what any enterprise when they move to the cloud, they expect to have a control and visibility of the resources which are they're running in the cloud, and how they can manage the consumption of the resources across multiple AWS accounts, or within AWS account, how they can manage different resources for different business units. Second challenge which normally enterprise face is with the integration challenge. Okay, once if they scale their infrastructure, okay, with however if they adopt any multi-account structure or multi-account strategy, okay, they normally face integration challenges with that. So uh, this is the common governance challenge which we have seen with a lot of enterprise customers, where they are facing integration challenges once they scale their infrastructure in the cloud. And third thing is that even though they have a multi-account structure, but they do not have any well-defined multi-account strategy. Okay, and that's where they commonly end up with a lot of issues in managing their infrastructure running in the cloud at this scale. And the fourth and last but not least is the delegation of responsibilities. So as the infrastructure grows in the cloud, they normally they face challenges in delegation of responsibilities, how to manage that infrastructure, how to have a standardized governance, all those things. So they normally face a lot of these challenges. So how to mitigate those challenges? So let's expect the need of R to mitigate all those common governance challenges which enterprise face once they scale into the cloud. So first one is automated provisioning. So as we discussed that, in order to achieve agility and control both from business and IT perspective, to have a strong business and IT alignment, we need to have something for automated provisioning of the entire infrastructure in place. Okay. Second thing is the compliance automation. So as the name suggests, we need to automate all the compliance controls and checks once they move to the cloud. And we need to see that how we can make our infrastructure which is running in the cloud secure and compliant for security and audit purpose. Third thing, as the name suggests, multi-account structure. So with the multi-account structure, we need to have a well-defined multi-account strategy. Okay, and how to you can say manage from the standardized point of view. Okay, so these are the four need of the hour. And the fourth thing is definitely the consolidated billing. So from the financial perspective, we often see enterprises are often looking for the consolidated billing of all the AWS accounts which comes under their purview, so that they can manage cost effectively across different business units. So how to actually get that all, how to mitigate all those solutions? So we have got a beautiful solution provided by AWS, is known as AWS Landing Zone. Before that, let's understand that why one AWS account is not enough for the enterprises which are actually quite big, and they are scaling their infrastructure on cloud. Okay, so these are the some of the key parameters which organization face, okay, or organization consider if they are running for one AWS account. So the first issue comes for the chargeback. So for the organizations which are running multiple business units and IT as a cost function, so the biggest challenge is that they don't have the control and visibility of the resource consumption across different business units. So they face difficulty in the chargeback of those resource consumption back to the business units. Okay, we have also discussed about security and compliance controls. So if any organization or any enterprise is running one AWS account, they normally face difficulty in implementation of security and compliance controls within a single account for different business units. So that's why it actually you can say produces a need for multi-account structure. Okay, sometimes enterprises needed isolation. Okay, a complete isolation, not only from the VPC perspective or from networking or security perspective, but also from the account perspective. So for that, also one AWS account will not be enough. Okay, and within any enterprise, okay, there can be different business processes and multiple environments like dev, UAT, or prod. Okay, so to isolate all those things, or to have a common so to have a consolidated billing of all those things, to have to charge back to different business units, one AWS account is definitely not enough. So what enterprise does, that they go for multi-account strategy. So even though they go with the multi-account structure with AWS, but still there are a lot of issues which we have once we have interacted with the customers. So they normally face a lot of issues with their multi-account structure as well. Okay, so they face issues that, okay, that we have provisioned different accounts for different purposes or different business units, but still we are facing issues with centralized management. Okay, there are no standard security or account level baselines which we can implement from a central point of view, and it can push to my multiple business units or multiple accounts running for my different business units. Okay, it still requires a lot of manual provisioning with high lead time. So even though I have figured out that yes, my one AWS account is not enough, and I need different AWS account for different purposes, my IT team is still requires a lot of lead time and still manually provisions all the infrastructure which is required for that. Okay, there are some issues with IT team as well, that still they have to manage multiple accounts, and they've got different distributed service management across different accounts. Even though they are running a centralized service management, but still for different account, they have got service management issues where they have to manually update all those accounts with service management, and in turn that leads to the distributed service management issues as well. Okay, from the financials perspective, since we are running multiple accounts, and multiple accounts corresponds to multiple invoices as well, so the finance department normally face cost management issues within a single enterprise organization. So what is the solution for that? Solution to all these problems is our AWS landing zone. Okay, so the AWS landing zone is a solution which is a purely pre-configured, secure, and scalable multi-account AWS environment. Okay, all the AWS best practices are actually implemented as part of AWS landing zone solution. So we'll see everything as part of the later slides, and I'll show you the live demo as well, where we will see that how different AWS services are stitched together to have a beautiful AWS landing zone solution, which is secure and scalable multi-account structure. Okay, it can act as a starting point for customers application migration journey as well. So for the enterprise customers which are you can say a big in terms of infrastructure workloads, okay, and they want to have a standardized policies or standardized governance across multiple AWS accounts. Okay, it can act as a starting point for their application migration journey as well. And I'll show you that how they can have a different multi-account structure, and how they can easily govern all those account structure within that AWS landing zone solution. Okay, so AWS landing zone solution, as the name suggests, it also provides you an environment that allows for iteration and extension over time. So it's a very scalable solution where everything is done automated way, and it provides you the environment that allows for iteration and extension over the time. So we'll see everything in detail now. So what a customer can expect from the AWS landing zone solution. So now we have discussed that what is the landing zone solution, okay, and what all those things actually comes under that. But what is the outcome which I can expect, what a customer can expect from AWS landing zone? Okay, so AWS with AWS landing zone implemented in the for their enterprise organization, a customer can expect a well-defined framework for creating and baselining a multi-account structure. Okay, and they can expect from the initial level a multi-account structure for the all the shared services and all the security and audit purpose as well. Okay, from the identity and access management, AWS landing zone uses AWS single sign-on service. Okay, and all those accounts which are created under that are managed via AWS SSO. From the security and governance point of view, which is a key topic for today's session. Okay, so we have got from multiple accounts created under AWS landing zone, and multiple accounts enable a separation of duties, which was the key governance challenge of cloud governance as well. So AWS landing zone provides not only from the account level baselines, but also provides the security and network baselines as well, to have compliance automation as well. So let's see how AWS Landing Zone mitigate all the cloud governance challenges which we have discussed. Okay, so let's discuss about what is the AWS Landing Zone architecture looks like. So AWS Landing Zone, as you can see here, that AWS Landing Zone is actually deployed using one of the services, which is AWS Control Tower. It implements AWS organizations, which actually acts as a centralized point of managing multi-account structure. Once these AWS organizations are created, we've got different organization unit under that. One is core OU, core organization unit, and another one is custom organization unit. The core OU is actually designated by AWS Landing Zone solution for all the shared services. So it basically creates by default two main accounts. One is the log archive account, as we can see here, and one is the audit account. So the log archive account, as the name suggests, it's actually used for all accounts logging purpose. All the account logging, all the CloudTrail logging, all the CloudWatch alarms, everything is coming under this centralized log archive account. Okay, and all the security uh, point of view from the audit perspective, all the cross account roles, all the account level baselines, security notifications are actually pushed to this security audit account. So as the name suggests, this account is primarily responsible for all the security auditors for your multi-account structure. Okay, so these are the two shared resources or two shared accounts which are created by AWS Landing Zone automatically once you implemented Landing Zone solution using AWS Control Tower, and that comes under our core organization unit. Okay, another organization unit, as we have discussed, is the custom organization unit. Okay, and this is the organization unit which is primarily responsible for all your application workloads. So under that custom OU, we have got you can create multiple accounts under that custom OU, and those accounts will be used to manage your application workloads. So in a nutshell, there will be no VPCs or any EC2 instances running over here in the log archive or audit account under core OU. All the VPCs and all the EC2 instances and all those services which you want to run in your AWS accounts will be part of your custom OU. Okay, but the best thing is that everything is automated in this AWS Landing Zone solution. So AWS Landing Zone solution provides you a service known as Account Factory. Okay, where you can automate all your account provisioning. So we'll see them in action in the demonstration as well when I'll show you the live demo. Okay, we have got Account Factory service, which basically uses AWS Service Catalog in the background to provision any new account. Okay, and all these new accounts actually inherit all those baselines, all the account and network baselines, which are you're defining under AWS organizations. So the benefit of implementing a landing zone solution is that you have an automated account provisioning via Account Factory service. You have a standardized account and security baselines, and using AWS guardrails, you can implement compliance automation as well. We'll see them in action as well. You have a centralized logging with the centralized log archive account. So all those accounts which are provisioned under that will actually push all those logs under log archive account. You have a centralized multi-account structure with authentication via AWS SSO service, and you will get what basically is required, very much required for governance and control perspective by the business, is that you get a simple and interactive dashboard for all your alerts and notifications for compliance management. So with that, let's discuss about three areas where Control Tower or Landing Zone solution works. Okay, so these are the three pillars of cloud governance where AWS Landing Zone works. First, it works at the account management level. You have a multi-account structure in a well-defined manner, okay, where they're controlled by AWS organizations. So we'll see them in action today as well. Okay, it also helps you to manage the cost for different accounts with all the consolidated billing under one account. Okay, it also automate all your compliance rules and checks. Okay, so let's see how AWS landing zone and what are the different services under that landing zone, which actually are associated with these pillars of cloud governance. So account management, as the name suggests, that we need to manage multiple accounts into AWS. Okay, and with that, AWS Landing Zone provides a lot of different services which it uses in the background to manage that multi-account structure. So if you see on the left-hand side, this is a multi-account structure which any enterprise has work, and they're facing some governance challenge. And once they implement a AWS Landing Zone solution, you have a well-defined AWS multi-account structure, which are managed under AWS organization. So AWS organization is a service which actually works at the central level, and where you can centrally manage all your multiple AWS accounts under that. Okay, as we have discussed in the architecture as well, by default under one AWS organization, it creates two organization unit, one for the shared services and one for all your custom accounts or provisioned accounts, which where you can run your application workloads. Okay, and this is the place where you can implement a standard account and security baselines for other accounts as well. So AWS Service Catalog is one of the key services also used by AWS Landing Zone. So as we have discussed that we can automate all the account provisioning using Account Factory. So I'll show you in the dashboard today in the live demonstration that how AWS gives you a flexibility to provision new accounts or new accounts based on the key requirement from your line of business, okay, using in an automated manner using Account Factory, which primarily uses AWS Service Catalog in the background. Okay, and also for the security and compliance and for identity and access management, AWS provides you policies structure as well, where you can centrally manage all the account level and security baselines using service control policies. So all your access management and control, okay, where business, there was a strong need of business from a centralized control level as well, are implemented using service control policies. So these service level control policies are basically in the background. There are IAM policies, identity and access management policies, where you can centrally push from the AWS organization to your respective accounts. And very important thing to note here that these service control policies override all your individual IAM policies as well. So if your account is being managed under one organization and you have implemented a service control policy for that particular account from the organization, so even if you create any IAM policy to override that, that will not happen. So service control policy will actually override all your IAM policies which are running in your respective accounts. Okay, so let's move to the cost management side. So even with the multi-account structure, when enterprises were facing challenges that how we can have a centralized management of cost for different accounts which are running in my organization, AWS organization also provides you consolidated billing as well. So once all the accounts are provisioned under AWS organization, the consolidated billing of all those AWS accounts comes under your master account, which sits at your organization. Okay, so all your billing of all AWS accounts comes under one master accounts, which is part of your organization. Okay, and with that, we, as we all know, that you can set different budgets and alerts for your cost potential overruns. So if you want to set a particular budget for let's say account A, okay, you can set that via AWS organization as well. So all your cost management is now centralized using your master account and AWS organization. So now the biggest question comes for those enterprises, or the biggest challenge which organization faces on the compliance side, how they can uh, automate their compliance and since they are running multiple accounts, how they can standardize those compliance. So AWS provides you different services under AWS landing zone solution to automate that compliance level checks and controls as well. So first service is basically AWS config rules. So AWS using AWS guardrails, which actually uses config rules and IAM policies to automate all the compliance level checks which are running in your respective accounts. So once these accounts are managed under a centralized AWS organization, okay, then you can push all the centralized policies or config rules from one place to your accounts. Okay, and once these accounts are enabled with AWS config rules or AWS guardrails under that AWS organization, then you can see all their compliance controls and checks in the control tower dashboard. From there, you can centrally manage your compliance rules, violations, and checks within that AWS control tower dashboard. So with that say, so you have got AWS guardrails, which actually automates your compliance rules and checks and violations within one central organization. You also get an interactive dashboard from AWS Control Tower, where you can see all the incompliant or whether that account is 100% compliant as per my compliant rules or not. Everything you can check and monitor from your interactive dashboard. And all these services are continuously monitoring using AWS CloudWatch service. So with that, that's the end of the presentation. So now let's jump onto the live demonstration. So this is my AWS Control Tower dashboard. As you can see here, that I've already implemented. Sorry, the session was expired. Let me quickly do that again. So AWS Control Tower actually takes approximately 60 minutes for implementation of AWS landing zone solution. So as just to save the time, and since we are running behind of time, so I've already implemented Control Tower service for you. So let me show you the Control Tower dashboard. I'm currently logged in as my root account or my master account, which is created under AWS organization. So let's see on the Control Tower dashboard first. And in parallel, I'll just show you how AWS manages multi-account structure. So you need to go to AWS organization. Okay, once you implement AWS landing zone, organizations actually gets created automatically, which links with your the root account. So this account I'm currently using as my root account. It also acts as my master account, where I can manage all my policies and my controls and all the control tower related stuff from this master account. So as you can see here, if I go into my organize accounts, so AWS landing zone, as we have discussed in our presentation as well, it has created two organization unit. One is for the shared services, which is core, and one is for your provision accounts, which is a custom. So if you click on core, you can see by default it creates two accounts, log archive and audit account. Okay, you just have to provide the correct email address for these accounts, and it will create automatically for you under that core account. And within that custom account, normally it creates an empty custom OU, but for this demo purpose, I've created two more rather accounts under that custom OU. So we are going to use this account, new account one, for the compliance check and everything I'll show you to you. Okay, so if you talk about the structure, so the structure is like that under root you have two OUs, core OUs and custom OU. The core OUs as is primarily used for all the shared services account, which in this case is log, archive, and audit. And the custom OU is primarily responsible for your provisioned accounts or all the accounts which are being managed for application workloads. Okay, and this is the tab which is very important. Okay, and here you can see that I have different kind of policies which I can enable for centrally via this uh, AWS organization tab, and I can push all those policies to my provisioned accounts which are managed under AWS organization. So let me show you on the service control policy. So you have different kinds of service control policies which are automatically created, but your AWS also creates you, gives you an option to create a custom service control policy, which you can attach to a particular account, and it will override all the IAM policies which are created natively in that account. So just for this demo, what I have done, so let me go to my custom account. If I click on new account, I can see on the right hand side that what are the service control policies which are attached to it. As of now, it is attached to full AWS access. But the policy which I would like to show you today as part of today's demo is the tag policy. So I've created a custom tag policy where this policy, if you see here, so this policy basically says that any resource, any EC2 instance, which is if you apply any tag for cost center, the only values which are allowed is DevOps, HR, and CopBU. Any other values, okay, if you want to apply for that particular EC2 instance, that will not be allowed because that is blocked, or you can say denied from this tag policy, which are attached to this particular account. So I have attached this policy to my new account one. As you can see here that this policy is attached to this. Okay, now let's actually go to my control tower dashboard. So this is my control tower dashboard. Here you can also see the two OUs and accounts which are created under that. So you can see on the OU side that one is my root account. Okay, under that root account I have got two OUs, core and custom. And under that core OU you have got two accounts, and under custom I've created two manual accounts under that. So you can also check on the accounts tab, and here you can see that these are my shared services account. One is audit account and one is my log archive account, which are created under core OU. And these are the accounts which I have created or enrolled using account factory under that custom account. And this is the place where you actually automate your account provisioning. Okay, so you have to just enroll the account. I'm not going to show you how to enroll the account. It normally takes time to enroll a particular account, but here you have to provide your account email, account name, what is the SSO email, SSO username, everything, and under which OU would like to create that account. So it's basically that simple. So so with this AWS account factory, you can automate your account provisioning under that custom OU. And this is the tab for your network baseline. So all the accounts which are enrolled or created using this account factory will have standardized network baselines pushed from this control tower. So as of now, you can see here that I have allowed internet accessible subnet. So with this, it will create some public subnets in the account which I am going to create. Okay, the initial VPC subnet I have mentioned over here. The region for VPC creation, I'm mentioning that I'm creating this account and VPC in USDs. Okay, this private subnet which I'm expecting is 2, and this is for each availability zone. So each availability zone will have 2 private subnets. Okay, So what I have done is that I've already created enrolled an account for you. Okay, I'll show you that how these network baselines are pushed, and now they are being managed using AWS Control Tower. Okay, before that, let's also see the guardrails. So these are the guardrails basically which are for the compliance automation. So as you can see here that a lot of guardrails are automatically created for you. Okay, so they basically what we need to understand here is that there are two types of guardrails which are provided by AWS Control Tower. One is preventive guardrails and six are detective guardrails. So 20, as the name suggests, preventive guardrails, it actually restricts you which violates these guardrails or these policies. Okay, so if I click on that, and you can see here, let's say, okay, if you want to I mean, if you just try to disallow change to any CloudWatch setup by AWS Control Tower, so that will not be allowed. Okay, because it's a mandatory one and it's a prevention one. So you will be denied access to make any changes for CloudWatch setup which is already done by AWS Control Tower. So you cannot do that. So these are the preventive guardrails. And if we talk about the other types of guardrails, which are detective guardrails. So detective guardrails, as the name suggests, is basically for detection. Okay, so as of now, what I have done that I have enabled these some of the detective guardrails to my new account, which is my custom account. Okay, so as you can so we will see here that if anything goes beyond that, okay, if anything is not as per these compliance rules which are allowed here. So let me show you. So this is one of the guardrail which is of the type detective. Okay, so I have actually attached this enabled this guardrail for one of my organization units, which is my custom one. As you can see that the organization units enabled for this guardrail is on the custom account, so custom OU, and all the accounts which are under that OU, it will be enabled for all those accounts as well. Okay, and just to show you what I have done, that I've created a volume, an EBS volume. Okay, and I have not attached to any EC2 instance. So that actually violates this particular guardrail, and you can see that status is in violation. And from the dashboard, you can easily see that which of my AWS accounts are compliant as per my guardrails or not. So as you can see here, these are my non-compliant sources. So you can see here that this rule is violated here, that disallow EBS volumes that are unattached to EC2 instance. Okay, it has also detected that which is the volume ID. Okay, and you need to fix that. It also enables, it also gives you uh, one of the guardrail which is also detected, that enable encryption for EBS volumes which are attached to EC2 instance. So what I have done that um, uh, deliberately I did not enable encryption for that EBS volumes. So that's why it is detecting that this is one of the compliance violation he has detected. And as you can see that from the AWS, sorry, from the control tower dashboard, okay, now this account is actually non-compliant. Okay, rest of the accounts are compliant, but this account is non-compliant due to these resources. And once you fix these compliance violations, you'll be able to see that this account will become compliant from non-compliant to compliant. Now, let me show you the account which is created for some OU. So this is my SSO console. This is my SSO console, and every time all those accounts which are managed under AWS Control Tower, you'll get an SSO link which you can share with your account admins, and they will manage all the accounts under this via this SSO URL only. So if I go to my VPC, so today I'm going now I'm going to check whether it is actually taking all my network baselines from my control tower or not. So if I click on VPC, So I can see that by default, once this account is provisioned using AWS control tower, it actually one VPC is created, and you can see here the subnet, the IP CIDR range is also from the same baseline which we have already created. You can see a lot of subnets are also created as per our requirement, which we have kept in the network baseline. You can see that for each for each availability zones, you have got private subnets, and for each AZ there is one public subnet as well. So you can see public subnet 1, 2, and 3. And for all these private subnet, automatically you've got all the NAT gateways also created. So everything is automated. So this is how AWS organization or AWS landing zone actually pushes all the standard network baselines to your respective accounts which are provisioned under that. So this actually is quite fast. Within you can say 30 to 40 minutes, you have all the you have a complete account ready with all the network and security baselines, and these accounts are then continuously monitored from the control tower dashboard and respective monitoring tools. Okay, and quickly I'll show you the violations which I have done from this EC2 perspective. So I'm running this EC2 instance as a part of demo, and if I go to the volumes, so this is the volume which is being used by this EC2 instance, and this is not encrypted. So that's why my guardrail is actually showing that I mean, it actually actually ask you to enable encryption for EBS volumes, but since it is not encrypted, so it's showing that it is a violation from my compliance rules, and so it actually detects that and provides you that notification to your dashboard, and then you can contact your respective account owner for that new account one, and you can ask them to fix it because it is not as per my compliance rules. Okay, another thing which says that disallow any EBS volumes that are unattached to EC2 instance. So for that, what I have done that I've created a spare volume, and it automatically detects that I found a compliance violation in that particular account. And as you can see here, that this is a volume ID which is detected by AWS Control Tower. So it becomes very actually easy, where you have an interactive dashboard where you can see all the accounts which are being managed under one control tower. You can see all the accounts whether they are compliant or not. Okay, and within this master account, if you go to the consolidated billing, you can cost management, you can see once you get the bill, you will see that what are the different services being consumed for different accounts for that. So this becomes your single pair account as well. Okay, so with that, it's the end of my session. So let's jump on to questions. Over to you, Angel.
Thank you, Tushar. Now let's have a quick look whether we have any questions from audience. Yes, we have one question from Arun Gupta.
Mhm.
And
How do you tackle the challenge of using AWS landing zone for existing customers who has already created their landing zone before the service was introduced? Okay, so AWS landing zone is not a new service. Rather, AWS Control Tower is a new service. Okay, AWS landing zone is a solution which is there for a while. Okay, so earlier there was another way of implementing AWS landing zone solution using CloudFormation templates, where you can actually have a multi-account structure created under AWS organization, and you can also invite existing AWS accounts to be managed under AWS organization.
thank you, Tushar.
Yep.
Let's have any other questions.
Any further question?
Yes, we have some questions from our community. And okay, we have one more question.
Mhm.
It is from Vignesh. He is asking if he already added an account under his organization with the proper policies and complaints already set up.
How
How do
difficult is it? switch that account to a standalone. Okay, that's a very interesting question actually. Normally, enterprise don't go with that. Once it is managed under AWS organization, they normally leverage all the benefits of AWS landing zone solution. But still, if there is a requirement, let's say they created an account for a business unit, which they thought that we are going to create a new business unit and we are going to create a new AWS account under that organization. Okay, and after that, that business unit dissolves. Okay, and they want to delete that account. So it's quite easy actually. So being the control tower administrator, you have the flexibility to remove any particular account from AWS organization. So it's quite easy. Okay, and that account will actually transform into a separate payer account as a standalone account. Vignesh, I hope it's answer your question.
Okay, thank you. We can see if we have any another questions. Yes, there is one question from Uma. Difference between AWS tower and AWS landing zone, and when we should go for AWS landing zone.
Okay, so I mean, this is a quite common question which normally comes into different minds when they uh, hear of AWS control tower and AWS landing zone. Okay, so guys, very important to understand that AWS control tower is a service to deploy AWS landing zone solution. AWS landing zone is not a service; it's a solution. Okay, AWS Control Tower is an automated service to automatically deploy your AWS Landing Zone solution. So if you go for AWS Landing Zone solution, you have now, as of now, you have got two options. You can either use standard CloudFormation templates to deploy your AWS Landing Zone, or you can use automated manner for using Control Tower. But however, very important thing to note here, that AWS Control Tower is as of now available in very limited regions. So you have to actually plan your deployments accordingly.
Thank you. Let's take. We have any other questions?
Yep.
It is a question from Hari. Is it possible to add our custom policy?
Yes, yes, you do have. So as I have shown you that from AWS organization, okay, you have an option to create your service control policy, which you can attach to your uh, accounts which are provisioned under AWS organization. However, in addition to that, AWS does not restrict you to create your custom IAM policy, which you can create under your provisioned account. However, which we very important thing to note, that if it conflicts with the service control policy which is pushed from the AWS organization, so service control policy will take precedence over that.
Okay, thank you. Let's check if we have any more questions.
Sure.
Yes, we have one more question from Vinay. Any automation landing zone for programmatic account deletion? Currently, we
Yeah,
are it's manual
we handle
process.
it to the manual step. Yes, Vinay. So that's an interesting question. So it's not hard, you can say, mandatory to actually go for the manual step. Okay, you can go for the programming account deletion as well. So AWS provides you the CLI steps for that as well. So where you can use AWS CLI, and you can use a lot of scripts for programmatic account deletion as well. That is possible.
Okay, thank you. We have one more question from
Mhm.
Rahul Maheshwari.
Mhm.
Currently, what are the orchestration options available and supported with custom built landing zone?
Okay, so orchestration, as I show you that uh, if you talk about the base landing zone, okay, where the two standard shared accounts like security audit and log archive, that is done via AWS Control Tower. But still, if you want to have some more options or some more services services associated with that landing zone, you can use CloudFormation templates. CloudFormation templates are readily available for a lot of solutions available to have a custom built landing zone.
Okay, thank you. We have some more questions. It is
Yep.
from Vita. Does
Right.
AWS landing page allows to migrate policies and rules or guide rail from one control tower to another tower, one organization to another organization in case of mergers or acquisitions?
Okay, so what you can do, if I mean that's an interesting question. So in case of merger and acquisitions, what happens is that two companies acquire or comes under one company. Okay, and now it is actually uh, the parent company or the company which is acquired to decide that which organization they would like to have one thing. Okay, if they want to have two organization still created after merger and acquisition, they can do so. And if I talk about migration of policies, so you have to create a manual service control policies, okay, from one organization to another. Both organizations actually are different to each other. And if we say on the within one organization, you can easily switch all the service control policy where for different organization unit. So what we suggest that in those case where merger and acquisitions are happening, okay, we normally recommend customers to go for one organization as part of now the combined organization after merger.
Patricia? Let's move to the next question. It is from Ram. What is the recommended model in a multiple account? Example,
Mhm.
in a single environment, we have database in different account and rest of the tiers in different account.
Okay, it all depends actually on the architecture which you are creating. Okay, with different accounts comes different challenges as well. Okay, so you have to manage all the routing using either transit gateways or VPC peering. Okay, so you can do that. Okay, and if your organization actually allows you to create that architecture to have different tiers into different accounts, you can do that, but that is not a recommended model. Okay, what we recommend as part of best practices, that all the tiers of an application, whether it's a DB, a web or app tier, okay, should lie into the same account. However, what you can do that for same application, if you want to segregate your environments like dev UAT environment, you can do so into different AWS accounts.
Thank
However, from the tiering perspective, you should actually keep that in one account.
thank you, Tisha. Let's go on to next question. It is from Philip. As a cloud migration expert, what is the biggest challenge you have faced?
Oh, okay. As a cloud migration expert, okay. So the challenge which we normally face during cloud migration is on the application dependencies. Okay, so if there are a lot of application dependencies within an account, and customers do not have the right bandwidth, okay, if they don't order direct connect, if they don't have the right bandwidth, so that is the main challenge which we have faced in the data migration. Okay, so since we have to create a lot of migration move groups, and we have to plan for migration waves while doing the migration. Okay, so the biggest challenge comes when one tier is actually running in the cloud, and one tier remains on premise for some point of time. Okay, and in that case, in order to have that same level of performance, you need to have good kind of connectivity. So this is what we suggest multiple customers as well, that if you are going for an enterprise migration, okay, where it is a heavy data requirements from the application perspective, you should actually at least from that perspective, you should go with the direct connect to have seamless experience.
Okay, thank you, Tisha. I think we have one more question.
Yep.
Let me check.
Sure.
Okay, we have some questions from our community, and
Mhm.
I would like to ask you about that.
Yep.
We would like to know about your favorite service in AWS and why
Okay.
this.
Well, AWS actually, I mean, does not differentiate between the services. So I love every services which I use. But as part of migration, we use quite a lot of database migration service. Cloud Endure is one of the very interesting tool which we use for migrations. Okay, and definitely the endpoints, VPCs, S3, these are the common services which we normally use as part of that. So I really love that. Actually, it's quite easy to work in AWS.
Okay, thank you, Tushar, for the wonderful insight. I hope all of you enjoyed the session as well. If there is any additional question from the attendees, Tushar, we will pass it to you. Please log into YouTube and you can directly comment there as well.
Sure,
Thank you.
sure. Thank you.
Don't forget
Thank
to
you,
share
everyone.
in the
Thank
social.
you.
Thank you. Hi everyone. Don't forget to share in the social media. You can use the hashtag ACD India and AWS UG India. There are exciting prizes for the best tweets and shares. Thank you.
Okay. See, please.
Alright, don't forget to share your feedbacks via Lanyard. Let's dive into our third technical session for today. Let me introduce Mike Chambers. He's one of our AWS machine learning hero. He's an independent trainer specializing in AWS and machine learning. He was one of the first in the world to become AWS certified and has gone on train well over 250,000 students in the art of AWS, machine learning, and cloud. He is joining us from Australia. Mike will be talking about going viral with AWS, artificial intelligence, machine learning services. Welcome, Mike, to AWS Community Day. Over to you.
Thank you very much. Thank you. So first of all, I just want to say a huge thank you for being invited to be at this session. The Indian community, the Indian AWS community, is very dear and near to me. You guys have supported me so much, and so thank you for having me here. So to get going, hello, yes, my name is Mike, and I'm going to be putting this presentation. This presentation is going to be showing how I've put together a little bit of a fun, interesting architecture. So we've had a lot of really in-depth and really awesome presentations so far today. This is going to be a little bit of light relief, but I'm going to show you how I use some of the services inside of AWS to make something a little bit fun using artificial intelligence and machine learning, video, And also, it's all going to be wrapped up in a serverless architecture. So thank you for my awesome introduction, but I am going to tell you a little bit more about me. So yes, I'm an AWS machine learning hero, and that happened just a couple of months ago, and in no small part due to the support that I've had from India. So again, thank you so much. What I do in my day job, if you like, is I help people to help them learn about machine learning on top of AWS. And if you'll give me a little bit of time at the end of this presentation, I'll tell you a little bit about the course that I'm putting together. It's targeted at the AWS Certified Machine Learning Specialty Certification, and I'll tell you a lot more about that in a moment. Now, something else that I want to tell you about me, and not a lot of people know this, I used to work in television. So I used to be a technical director for a live news production organization over in Europe when I lived over there. And it's through working in television, that I kind of found that I had a dislike for video editing. Now, don't get me wrong. I like editing together my own videos. I like editing together my sort of holiday videos, but editing other people's videos can be really tedious. And so that was kind of the inspiration behind the project that I want to show you now. So let's dive into it. Let's look at what we're going to look at during this session. Video creation. Now, most people will think, and I would forgive anybody for thinking, this is how the video creation process works. We record some footage, whether that be on our mobile phone or with a whole TV crew. We then edit it together and then we shove it up on the internet somewhere and people watch it. And broadly speaking, I guess that's right. But really, if you think about it, and if you tease it apart a bit more, it's actually quite a bit more complicated than that. And so I'm going to propose to you now that actually it looks a bit more like this. So we record some footage, again, on a mobile phone or a laptop or with a film crew with you. We then have to create a shot list, or we have to start cataloging the video that we've got. We have to know which bits of it are going to make it into our final production. Then there is that decision-making process. Someone's got to decide what it is that's going to make it into our final video. Someone's got to decide what bits of film tell the story that we want to tell. Then we can move to an editing process, which is really kind of just a run-of-the-mill kind of just cut and paste exercise at that point, before we then move on to a rendering process, which is, I guess, a kind of technical output of the edit. Then we might have to transcode our video. So depending on where the video is going to go, we might have different kinds of bit rates, different kinds of codecs that we need to use. And so there's that transcode job. Then the video is available on the internet or wherever for people to be able to watch. So I'm proposing to you that really, whether it's implicit in what we do just because we're kind of good at it, or whether it's a very specific function-based, this is really the kind of process that we go through in order to be able to create videos. So that got me thinking, with all this power of the cloud at our fingertips, what can we do? And this is what I'm proposing we look at doing in this session today. This is the aim for today. We're going to have some footage. So we're not going to record footage. We're going to have some we've already had provided for us. So we've got our recorded footage. We're going to do some AWS cloudy automation things. So we're all quite familiar, I guess, with cloud being the platform for automation. There's a lot we can do in there, and that's what we're going to look at in this session. And then we get a video out the other side. I don't want to have to deal with the editing. I want the cloud and the solution that we build to do all of it for us. Now, the solution that I'm proposing and what I'm going to show you today, it's a little bit fun, but the tools that we're using, the services that we're using, could definitely be used in more serious business level applications as well. So there's a little bit for everybody. Now, I wouldn't be much of a solution architect or a systems analyst if I didn't have a bullet point of lists of requirements. And so I'm not going to have tons of bullet points in this presentation, but there are going to be some on this slide. So what do we want to be able to achieve? Well, we want to be able to listen, or I guess watch the video we have to have something in the process that does that, because we don't want to have to do it. Then we have to have something that understands that video. So understands what's inside of it so that we can start to make a decision. We need to decide what it is that we're going to edit. So you'll see now that these bullet points, I guess, align to that diagram that we looked at just a moment ago. And then once we've made that decision, we need to have a process that does the actual editing. So we need to actually edit the actual file, spit it out, transcode it, do everything else, and orchestrate the whole thing together. So we need to look for something that's going to do that for us as well. Now, those are all, I guess, what I might classify as functional requirements if I'm putting that kind of enterprise language hat on. Let's look at the non-functional requirements. I want it to be robust because I want it to just work when I submit a video to the system. I want to make sure that I don't have to look at it again. I want low management, and I want it to be highly scalable. I'm not really sure why I want it to be highly scalable, because it is just me, but maybe we could roll this out to everybody in the world to create their viral video sensations. So it needs to be highly scalable. And I guess it's just part of the challenge. So with those two lists, if you like, of requirements, let's have a look at what kind of, broadly speaking, what technologies we can use to throw at these. And what I'm going to suggest to you is that we're going to use artificial intelligence, not exclusively, but predominantly artificial intelligence to do the exciting bits of the listening and the understanding of the video. And then we're going to use serverless technologies on the other side, because honestly, everybody wants serverless in their applications. Everybody wants serverless in their presentations. So I'm catering for machine learning, artificial intelligence, and serverless. So surely I get all the ticks with this. And the final thing that I want to do is I want to build it entirely on AWS. Now, that's not a real world, real requirement, right? You use the best service that matches your requirements. But I tend to find that most of the best services live on AWS anyway. And for this particular project, I wanted the challenge. So I wanted to do it entirely with AWS services, which was a little bit of a challenge. But I found, spoiler alert, you can absolutely do it. And I'll show you how. So let's jump into the process. Let's talk about how I did this, but at a higher level to start with, before we dip into the actual console itself and have a look at some of the running code. So the first thing we need to do is we need to listen to the video. That's what we've established. And so we actually need a video to actually listen to. And so the video I've chosen for this is Andy Jasay's 2019 reInvent keynote speech. I didn't necessarily ask to do this, but I'm sure he's fine with it. It's 2 hours and 40 minutes long. So it's really quite a long video. And it's useful from that point of view to demonstrate what we're going to do here, because the last thing I want to do, well, no, hang on. I absolutely did listen to this live when it was on, but I don't want to have to listen to it again in order to be able to figure out which bits I want to edit from it. That's my excuse anyway. So how can we listen or watch this video automatically so that later on we can decide what to edit out of this video? And the service we're going to use for that is Amazon Transcribe. Now, Amazon Transcribe is an artificial intelligence service that sits inside of AWS. And right now, what I'm probably going to do is I'm just going to pause for just 1 second. And I'm going to hop over to a slide, which is actually from an AWS slide deck. So I didn't make it, which explains a little bit about the machine learning and artificial intelligence services that are available from AWS. And we'll see where Transcribe lives, as well as some of the other services that we're going to use today. So here is the slide. Again, I didn't put this together, but it's nicely and succinctly explains, I think succinctly, you might have to zoom in a little bit, but it explains the different frameworks and services that AWS have in relation to machine learning. So down the bottom there, not actually where I'm highlighting with the pink box, never mind. Right down the bottom there, you'll see the ML frameworks and infrastructure. So these are essentially the ultimate building blocks for machine learning. And broadly speaking, they're actually the building blocks for machine learning generally. So we've got frameworks like TensorFlow and MXNet. We've got abstractions of those like Gluon and Keras. But we've also got the actual server infrastructure as well. Server infrastructure that AWS has specifically put together to cater for machine learning workloads. So we've got servers with GPU acceleration, with special elastic inference endpoints, all of this kind of stuff. So really sophisticated low-level infrastructure down at that level. Now, using that is a little bit complicated, and it's certainly beyond the scope of what we're going to talk about here today, and it's certainly beyond the scope of the project that I've put together. So let's walk up the stack and look to see what AWS have done to make machine learning a little bit easier inside of the AWS environment. And if we go up one level, we have that level in the middle there, which is called ML services or machine learning services. And predominantly in that layer is Amazon SageMaker. Now, Amazon SageMaker isn't actually a service, I don't think, in that way. It's more of a collection of services and collection of API endpoints. It's documented examples. It's environments you can develop in. It's container images. It's a whole bunch of stuff. And the SageMaker Studio IDE as well, all thrown into here. So it's a very capable environment, if you like, and collection of things that somebody who would say that they're a machine learning operationist, an ML ops operator, could live in there quite comfortably, deploying infrastructure and building machine learning solutions. And it abstracts away from those frameworks and from that infrastructure to sort of do the undifferentiated heavy lifting, which of course is AWS's famous marketing term. But that itself as well, that layer requires still some specific level of knowledge to be able to get the best out of it. You can build your own models. You can do a lot of very sophisticated things in there relatively easily compared with doing it from scratch. But on top of this, AWS have built their AI services. And you can bet that the AI services that they've built make use out of everything else that's in the stack there. But they've built them for us to be able to get easy access to really powerful machine learning solutions. So right up at the top there, we've got API-driven services. So if we want to just write an app, we can bolt in these different services to do really powerful machine learning activities. And one of those is Amazon Transcribe, which is just here. And that's what we're going to use. And we're going to talk about how that works. And we'll use some other services from this layer as well throughout the solution. But a really important point that I want to get across here is that just because these are abstracted services and they're available at an API level, that doesn't mean that they're not powerful. They're actually very powerful and can be used for production workloads. So they are absolutely to be considered. If an AI service does what you need, you should think about using it rather than building your own, because that's, I guess, the entire philosophy around cloud computing. Okay, so let's move away from AWS's view of their own machine learning services, and I thank them for kind of letting me borrow that slide. And let's go back to my presentation and where we're going to use these AI services to automatically edit my video. So we use Amazon Transcribe. We take the video that we have, all 2 hours and 40 minutes of Andy talking, and we present it to this service. We then have to wait a little while, but whilst it churns through that, it transcribes that video into text. And so hopefully you can see here, and I can show you this in more detail when we jump into the console. But here is a snippet from the first part of the response, where it's telling us the text that's inside that speech. And as you can see there, it's thank you, hello, and welcome to the 8th annual AWS reInvent. It's quite a natural thing for him to be saying at the beginning of the presentation. Now, that is then followed by all of the rest of the text. All 2 hours and 40 minutes of the text is all together in this one big chunk of text. And interesting while that is, it's not really that useful for us when we want to edit that video at a later stage and figure out what words we want to edit. So there is another part of the response from Amazon Transcribe which will help us out. And that's this part, which is underneath. There's a second part where it takes each individual word transcribed from that video and tells us the start time of that word and the end time of that word. So in seconds, or seconds and hundredths of a second, it tells us the start and the end time of that word. So this is starting to become much more useful when we are wanting to sort of place a marker in the video and do some editing. So Amazon Transcribe, it caters for the listen aspect or the watch aspect of our video. Let's move on then to understand. And to understand, we're going to use another one of the artificial intelligence services, the AI services from AWS. And this one's called Amazon Comprehend. It's in the name, right? It's going to comprehend something about the text which we've just got back. Now, Comprehend is a fairly large kind of Swiss Army knife of natural language processing. It can do quite a lot of things, but we're going to look at one thing in particular, and I'm going to talk about a couple right now. So we can take the individual words that we have, and in the final solution, we're not necessarily going to take all of them, but we'll take some of the words. We can pass it into Comprehend, and it can tell us what the language structure of that word is. And so in this particular case, you can see a little snippet that's returned back from the service, which tells us that the word more is an adjective. So we've asked it to tell us about more, and it's told us that that's an adjective. Now, that's a really, really simple use case for Comprehend. It can do so much more than that. And if I wanted to, or if you wanted to extend this project out further, this is a fertile place to do just that, to look at how we could comprehend or understand the video even more. And one of those things is we could look for sentiment analysis. So Comprehend can do this. So we can pass in sentence structures even into the service, and it will give us the sentiment of that sentence structure. So here you can see an example of a return for such a call. And we've said, give us the sentiment of this, and it said, it's positive. And you can see there the sentiment score. It's got the positive, negative, neutral, and mixed. That's not necessarily how positive it is or how negative it is necessarily. It could be more aligned to how sure Amazon Comprehend is that it's positive. But nevertheless, there's sort of 6 of one and half of a dozen of the other. You can use that to gain the sentiment of the text that you have. Now, we don't do that in this solution. We're going to stick to the adjective thing from before. So we have there with that service, with Amazon Comprehend, a way to understand the video that we're going to try to edit. And everything so far has been serverless. We haven't had to touch a single server. So the next thing that we need to do is we need to decide, if you remember from the bullet point list that we looked at before, we need to decide. Now that we've got all this information from the video, we need to decide how we're going to edit it together. What are we going to take from the video and put it into our edit? And so to do that, as you can see, I'm going to use a Lambda function. Lambda function, of course, is the serverless code that we can run. And with that small piece of code, I can codify the rules that I want to have, the logic that I want to have, that will decide how to edit this video together. Now, it can't do the actual video editing, but it can decide what the edit will look like. So if you remember from our trace through of all the different steps, it's that last person before edit. So with this Lambda function, we're going to take the transcription that we've got, we're going to pass it into the Lambda function and ask it to do some analysis on it. And in this case, it's just going to look for all of the words in there. It's going to look for the most commonly used words and find the first word, which is an adjective. So something which describes what is going on in the presentation. So we could well expect this to be like great or better because Andy's very passionate about what he talks about on stage, and everything at reInvent in the keynote is bigger, better, shinier. You get the idea. So we pass the transcription in. The Lambda function will use the language capabilities of Comprehend to find the first adjective. And then we can just do a bunch of processing on that and spit out an EDL. Now, an EDL is a video term. It's from back in my TV days, but it's an edit decision list. Essentially, all we're going to do is output a text file. And inside of that text file, we'll have an in point and an out point for all of the different clips that we want to clip together. And so in this case, it's going to be the boundaries of each of those words that we want to edit into our final video. And that gets stored out in an S3 bucket as our edit decision list. Okay, so now we've finished sort of deciding what we want, and we've even noted down all of the clips that we want. The question now comes, how can we edit this video? And when I was putting this together, this is what made me scratch my head, because I wasn't quite sure. I did start to play around with EC2 instances or Docker containers that had open source libraries inside of them that could do this kind of stuff, and it kind of worked. But managing those kinds of things is a bit of a headache. That's why serverless is a thing. I don't want to have to manage servers. I want it to be robust. I don't want to have any management overhead of patching them and all that kind of stuff. So I was very happy when I came across AWS Elemental Media Convert. Now, the reason why I'd passed it by in the past was because it says Media Convert, and that's great. We've had Elastic Transcoder for a while, and that can also convert media types. I'm sure this is more capable. But one of the things that this can do, if you dig in the documentation, is it can take, essentially, an edit decision list, and it can only transcribe or convert particular parts of the video and edit them together and spit them out. This is fantastic. This is exactly what I wanted. So we're going to use AWS Elemental Media Convert as a serverless video editor to take that decision that we've got, which is set up inside of our S3 bucket. We'll pass that into a Lambda function, which can call Media Convert in the appropriate way, because we can't just throw a text file at Media Convert. Kind of. We have to call it through our Lambda function. So we'll do that, and then AWS Elemental Media Convert will spit out an output into our output bucket. And at that point, we will have edited a video automatically. Whether you think it's of any use or not, it's up to you. It's kind of funny, but absolutely the components that we're looking at here could be used for serious applications as well, if serious is your thing. So let's take a look. Let's take a stand back at all the different services that we have identified and that we're going to use. We've got a bunch of S3 buckets. We've got Lambda functions, which are going to be used for certain things, the AI services, and the Media Convert service as well. So the question now comes, how can we organize this process? How can we have it all orchestrate together? And so we now step into serverless architectures. And the easiest, I guess, or the simplest or the most straightforward serverless architecture is event chaining. So we could have a look at doing this. So we could have an S3 bucket. So we get an S3 bucket. If we put an object inside of the S3 bucket, so for example, the video that we want to edit, we put that in there, it will create an event for us. And that event can be used to trigger something, such as a Lambda function, which can then be used to trigger something else. So we could get the Lambda function to send that job into transcribe. And this works well. We like this. The question comes, though, as to what we do next. We could output the output of transcribe into a bucket. And then we could have another event on that, which calls another Lambda function and chain things together that way. But the problem with doing it like this is that there is more to be done after this stage. So there's actually a whole bunch more stuff that we have to do. We need to, or we want to, maintain some kind of state throughout all these different steps. So we don't want to have to pass information between services that don't actually care about file names, for example, so that ultimately Media Convert will know what word we chose so it can name the file appropriately, all that type of stuff. That's state that we want to have sort of be in the background. So as we step through this process, we want to maintain state. And if you've used AWS serverless architectures, you're probably screaming this at me right now, or maybe it's in the chat, which, by the way, I can't see, but thank you for your comments. We're going to use AWS step functions. So AWS step functions can host state machines, and these state machines are responsible for orchestrating various services, predominantly in this case, probably Lambda functions, but they can also call out to services in their own right as well. And so we're going to create a little graph like this, which is going to link together the different parts of the process. So the transcription, waiting for the transcription to finish, deciding on what that clip word is going to be, putting the edit decision list together, and then passing the job to Elemental Media Convert at the end. And so this is what step functions does, and it does it very well. And it's another serverless service. So this architecture, 100% serverless, automatically edits our videos. But don't just take my word for it. Let's jump into the AWS console. if the demo gods will be happy and pleased with me and let me do this, let's see if we can get this working. Here we are inside of the AWS console, and we'll have a look at the different pieces and the bits and pieces that I've got that actually makes this work. So first of all, I'm going to go and have a look at my S3 buckets, and I'm going to actually kick the job off because it can take some time to do this. I'm not sure if we'll see one actually go through the process, but I've got some samples that I can show you, so don't worry. And so in this S3, in this account, I've got 3 buckets. I've got my input bucket, my output bucket, and I've got a clips list bucket as well. So this is where my edit decision list will go in. So the input bucket, as you can probably guess, is where we put the video, and we put the video in there. It's going to trigger off a Lambda function, which triggers off our step functions. So we're going to go and do that right now so that we can start the process. And a little trick here, if you do this kind of thing, yes, it does want me to essentially upload a video into this bucket, but that could take a little while. So what I'm going to do is I'm just going to rename this object. And renaming this object has the same effect. It will trigger off the function that will trigger the event in the same way with the way I have it set up. So I'm going to go into here and say actions. I'm zoomed well in here, so hopefully you can see what's happening, but it also means that everything's rather in unusual places for me. There we go. So we're going to rename it. Let's rename this 3 because I was testing with it earlier today. So I press the save button, and that will basically simulate that a video has just been uploaded into the environment. Okay, so now I've done that. An event has been created. It's triggered off a Lambda function. That Lambda function has gone and triggered off our step functions. And I can show you that by going over to step functions inside the console. So we're going to have a look over, over here. And you can see that I have one step function state machine defined, and I'm going to have to refresh this. And hopefully we'll see that it's going. Hang on, let's go back out. Let's go back to state machines. Yes, we do have one running. Here we go. We have one running here. Thank goodness. Let's dip into this and see if we can see it in process. So we see the executions. Yes, there we go. It's refreshed now. So we have this running occurrence of our state machine right here. So what this means is we are currently in the process of going through our steps of our machine. So let's just navigate into there.
Sorry to interrupt. Could you please
Yes.
refresh the screen?
Can I refresh the screen, did you say?
Yeah, yes.
Yes, I can. Are you unable to see it?
No,
Right.
it is like broken.
Yes, I see that as well. It's right in front of me. I wonder if I stop screen sharing and then start it again, whether that would help. Let's try it.
Okay.
This
Sure.
could all go terribly wrong, or it could be perfect. Screen share. So I am doing this from Australia with our internet, which is as good as it is. So I'm pressing screen share, and I'm now not getting an option to share my screen. Maybe that was the wrong thing to do. Oh, here we go. No, it's come up. So let's say there. Bear with me 1 second, folks. Allow. All right. How's that? You can see that now, yes. I don't know what the last thing was you could see, so hopefully it all made sense. So we've renamed the object inside of the S3 bucket, and it's now kicked off this, this state function, state machine, step functions, lots of names. And so if we look inside of here, we can actually use the graph inspector to show us what's currently going on. And hopefully you can see that. It's a little small. And notice that it's sort of a little bit not quite right in the live stream too, but you can see the actual step machine graph inspector. So at least that's good. So you can see there that it looks quite similar to when I had it on the slides before, but it's got a green box at the top there that's saying that the transcription job has been kicked off. And it is currently in the wait for transcribe section. So what's happened here, kicking off a transcribe job is an asynchronous call. So we say, please transcribe this video, and then it goes off and does that. But we have to sort of progressively ask are you finished yet? And so that's what this loop does that's here. So we actually have a Lambda function whose sole job in life is to go to transcribe and say, have you finished transcribing yet? And this is successfully running, but it's saying, no, I haven't finished. And so it's going round and round here in this loop currently. So we can see this in the definition of the step function, if everything catches up with me. And it kind of does. Maybe I should, if I scroll more, there we go. It's a bit strange there, but you can kind of see the code. And so this is how we define the state machine, the step function. And so we say which Lambda function we want to call, and then we can have decision points inside of the state machine to say, okay, we put a value into the state. Look at that value. If it's the value we're looking for, then carry on to the next step. Otherwise, go this other way. And that's where this conditional routing comes in. And so we've got something in here which is going to look for the transcription status as completed, which is right there. Hopefully you can see that. If it's completed, it'll carry on. If it's not completed yet, it will loop around again. Or if it comes back as failed, then we'll go to an error state. But so far that hasn't happened. That's just a catch-all just in case. So let's go and have a look at the video that I uploaded into this process. So if I just slide to my other screen, hopefully this will work. Hopefully you'll be able to hear it, because that's kind of the point. But this is Andy Jassy's keynote speech. Yes, it's 2 hours and 40 minutes long. No, we're not going to watch it all. So hopefully you can hear this too and see it somewhat. So
thank you. Hello.
Lots
welcome
of
to
copyright-related reasons, I'm not going to play the whole thing.
Event. It is awesome.
But hopefully you can hear that. Anyway, okay. So that's the video that we're going to ask it to transcode. Let's go and have a look at what the outputs look like at the various stages that we've got inside this code. So here, I've got the output of the transcription job. Now, this isn't the one we've currently initiated because that's still going, but this is one that I've done on this previously, sort of a ready-baked, if you like. And hopefully you'll be able to see this more or less. So you can see here at the top here, we have the transcript of the entire video. And if I kind of carefully scroll across, you'll see that it's really, 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 really long. Of course, this line represents over 2.5 hours worth of speech. So it's all in there. But if we just scroll down here, you can see what I was talking about before, which is the JSON structure, which shows us each individual word and its start time and its end time in there. And so that's the word thank and the word you, and then a full stop, and then hello, and on it goes. You can imagine this file is quite long. So that's what we've got that comes out of transcribe. Let's go and have a quick look at the Lambda functions that we've got. The streaming will allow me to show you. So let's go over to Lambda functions. Let's give you a sense of what I've got in here. And I can't go through all of this code because I'm no developer and you do not want to see much of my code. That's for one thing. But also, there's too much of it. So let's go and have a look in here at clipword, for example. So clipword is the function which is going to take the transcription and then try and extract from it the word that we are going to edit together, chop style, into our final video. And hopefully you'll be able to see some of this. Maybe I refresh the page. It is what you suggested, wasn't it? See if that sort of like gets the whole thing to refresh. I can see it in front of me. Maybe I should turn my camera to the screen here. You can kind of see it. Let's see what we can see. The idea with this then, this Lambda function, what it does is it takes the transcription job that's been done. Now that transcription job has been placed into the state of that step machine, of that step function. So the Lambda function just has to go and grab that, pull it in, and start to process that data. So it does that by doing a word count first off. Let's just see where that's done. You can just about see that. So it gets the word count. So it goes through every single word that's in that transcription, and it finds the most popular word. Actually, it ranks them all by unique words ranked by how often they're used. And then down here, this is where we go off and call comprehend. So we're calling comprehend directly from this Lambda function. But we don't call it for every single word that's in that list, because that would take forever and actually might end up being quite expensive as well. So we just send the first most popular word and then keep going down that list until we find the first adjective that it spits out. So that's what that's going to do. And that's the Lambda handler, which sort of ties the whole thing together. So then, if I just go back to my my Lambda functions, scroll to the top here, go back and have a look at them. We then use a different Lambda function to go and create the edit list itself. And this is a great example of chaining together our Lambda functions using the step machine sort of working for us. So rather than passing the message from the previous Lambda function that we looked at onto the next Lambda function, we just pass the output, in other words, the word that we're going to look for. We pass that back into the state machine, and the state machine has that available then for the next function in the loop. And it means that our Lambda functions are more loosely coupled. So let's go and have a look inside of here. And this Lambda function is going to pick up that word from the state of the step function state machine, and it's going to go and create that edit decision list that I was talking about before. And the only thing that this function has to do, which is a little bit quirky, is that it takes the time of each word, so the seconds and hundredths of a second, and converts it into seconds and frames, because now we're moving into a video editing world. And that's how we talk. We don't talk in hundredths of a second, we talk in frames. So let's have a look, rather than looking at this code. Hopefully this works for us, and it does. Let's go and have a look at the output of this function. And this is what it looks like. So very, very simple, very, very straightforward. You can more or less see all of this. You can't quite see the exact left-hand side of it, but that doesn't really matter. You can see the start time code, and the end time code, and that's all you need for every single occurrence of what we want to edit from this video. So that's what we've got inside of there. Now let's go back and have a look at our step function. I'm imagining that it's probably still going. Let's have a look at it. Yes, it's still doing the transcription, actually. So that whole process, the whole process of running this particular one on this particular video is about 15 minutes. And so rather than me just sit back and fold my arms and wait for it, I'm going to show you an example of what it spits out. So hopefully this works, and you could hear the video from before, because, well, this is it, folks. This is, I don't know, the viral video sensation that I've managed to make. Drum roll, please. It'll somewhat work. Hopefully you'll be able to hear it. So this is the 22-second version of that keynote speech.
So
hopefully, as you can hear there, I can't actually hear it, but through the magic of this streaming, hopefully you can hear that it's clipped together every single instance of the most commonly used adjective in the presentation. So there you go. Viral video sensation, I don't know. How could we extend this? We could make it so that it could automatically upload that to YouTube and have an entire channel of these things done. And I don't know. It's a fun project. I think it's a fun project. Okay, so that's still going to be going on for some time. We could come back and look at it when we get to question time if you want. But let's dash back to the presentation before I run out of time, and have a bit of a wrap up to see how we've gone with this solution. So what have we managed to achieve? Have we managed to achieve what we set out to achieve? Well, first of all, we wanted to be able to listen to the video. And we were able to do that with Amazon Transcribe, so an artificial intelligence service that all we had to do was throw the video at it, and it was able to transcribe that video for us without us having to do anything more. It catered for our needs. Then we have understand, and we've used comprehend to understand our video somewhat. But as I said before, the one place which is fertile ground for making this even more sophisticated would be to use comprehend a little bit more with a bit more sophistication to figure out maybe the parts of the presentation which have the highest sentiment, for the highest positive sentiment, for example. But I can imagine there'd be quite a lot of that going on in that presentation. We've decided what to do. We've figured out how to edit it, and we used a Lambda function for that. So we codified the logic that we had inside of that Lambda function. We then processed the video now, and that was partially done by Elemental Media Convert using the edit decision list that we created, and also using step functions, state machines, to tie the whole thing together. Was it robust? Well, pretty much, apart from the little streaming glitch. Trust me, on my side, it looked perfect. So yes, it's robust. It's running in the cloud. Low management because we're using serverless throughout, and highly scalable too. Again, pretty much because we're using serverless architectures. So Lambda functions scale really well. The artificial intelligence services scale really well as well. So we are able to have hundreds of thousands of videos at any time being processed through this architecture. So we've managed to do it. Let's just have a little bit of a grounding just for a second. In the real world, where could we use this? Well, clearly I could use it on my own YouTube channel to become a viral sensation, but parking that, what could we use it for? Well, I'm going to suggest to you we could use it for recording meetings, or we could use recordings of meetings and then look for certain things that happened in those meetings, especially if we've got archived footage of meetings. Maybe it's only audio. We could do the same thing. And we could pull out just individual parts that we want to highlight to other team members, for example. We could use it for media monitoring. So a lot of companies want to know what's being said about their company in the wild. So we could use media monitoring. We could have snippets of news coverage coming in, and we could look to see whenever they might mention us or our products. Maybe we could create a whole service around editing video, like a word processor. So we could adjust the words, and it would go and basically re-edit together our video for us. It'll take a bit more doing to get there. I think that's a pretty fun example of what you could do. And I want you to let me know if you've got any ideas what we could use this for. So I absolutely want to hear from you. In a moment, I'm going to put up my my LinkedIn profile. Get in touch with me on LinkedIn, and there's $50 AWS credits for the best answer. So that was just something I thought up just then. Absolutely, we're going to do this. $50 AWS credits for anybody who can think of a really awesome, fun or otherwise use case for this architecture that we've put together. So let me wrap up just by recovering what I was talking about before. Let me wrap up by recovering. That's not what I meant to say. Let me wrap up by talking a little bit more about what I do in my day-to-day. As I explained before, I help people get certified in AWS. I've been doing that for a long time. And right now I'm focusing on helping people to certify with the AWS Certified Machine Learning Specialty Certification. So the kind of stuff that we've looked at in this presentation, it is featured in the certification, but we go lower level as well. So we get into SageMaker. We look at how we can use SageMaker to build models. We also, though, look at how machine learning even works from the get-go. Let's talk about the fundamentals of machine learning so that you can build off of maybe your existing AWS knowledge up until the point that you could pass this certification, or even just using machine learning in your day-to-day, in your work environment, or for your own fun hobbies. So the link to this course is at the top of the screen now. So feel free to come along and have a look. I present lessons in a similar kind of way, I guess, to the way that we've done this session now. There's lots of slides and lots of animations, but we also get hands-on. So we absolutely dive into build environments, and we do real machine learning and real solutions with real machine learning algorithms, for example, getting down and using SageMaker too. So that's the course. And I explained right up at the top of this session how grateful I am to the Indian community in particular for the support that you've shown me over the years. And so I wanted to give something back. I was very, very grateful to be invited to this conference and to this day. And so, yes, drumroll please, I have got a code to give away for my course, and it's a whopping 50% off. So it's a special limited offer just for now. So please, do use this code. It's AWS UG India, the hashtag we're using for this event, and it'll give you 50% off this course. And it will be amazing to see you in on the course, going through your machine learning journey with me and with the rest of the community which is taking the course. It's in early access right now, which means that the course is still being developed. It's an ideal time to get in right now, whilst there's a lot of discussion going on about how the course can be best put together to show you what you want to see in order to be able to pass this exam. So go to this link, use this code, and please do also connect with me on LinkedIn. And don't forget, the best use case for what we've looked at in this presentation so far, there's a $50 AWS voucher, $50 USD voucher coming your way. So that's it. That's my presentation. Thank you so much for watching. If anyone's got any questions, hopefully you have, I'll be more than happy to answer them now.
Thank you, Mike. Now let's have a quick look whether we have any questions from the audience.
Surely one or two questions or ideas or tips.
Okay, the first question is sentiment analysis. What is statement is satirical? The system won't comprehend that, right? That's a question.
I don't. Is it a question? It might be more of a comment. I don't. So sure. So sentiment analysis is part of natural language processing, and at the moment, a lot of the effort around this is really just sort of focusing on things like the whether it's a positive statement or a negative statement, something like that. Could it detect satirical? Maybe. So the thing with machine learning generally is it's all about data. So if we can get together and gather together a lot of satirical information, then maybe we could build a classifier. But I got a feeling it might be quite hard. I'm not sure that comprehends quite there yet. But AWS, Amazon, more to the point, is collecting together information and data all the time. We've probably all got Alexas in our room, and I'm sorry if I've just set off everybody's Alexa. Mine's on mute, thankfully. And that sort of hoovers in lots of data and helps the big data companies of the world to put together as best a models as they can. So in time, maybe it is. And if someone knows that they're already doing this, then let me know, because that would be a fun one to see.
Thank you. There is one more question. If the Terraform is used for the Route S3 state, then how to ensure that Terraform lock works fine in remote state?
Interesting. I'm wondering whether that's a question for this actual presentation, because I didn't use any Terraform. So if the Terraform is to be used for the remote S3 state, then how to ensure that Terraform lock works fine in remote state? I don't think that that's a question related to this presentation, if I may say. If I'm wrong, then please let me know. But we didn't use Terraform for this. What we used S3 for was to obviously store the data, but also to provide event triggers to be able to trigger off Lambda functions and step functions and things like that.
Thank you, Mike. Let's move on to next question. And he's asking about, he has seen several of these kinds of funny videos in social media. Are those all created using Transcribe? In fact, are there any other tools present? Maybe outside AWS? Who does this transcribe?
I think I can say exclusively here now in this, all viral videos on the internet have been made with this process on AWS. That's sarcasm. No, that's not true. I'm sure that I'm not just going to say it's not happened. I haven't seen any videos that have said they've absolutely used this process. Most funny videos are created by people with their editing prowess, and they put together something funny. And obviously, the video I put together here maybe isn't quite going to make it viral yet. But maybe the question is more about yes, there are videos out there that have been made which have actually done quite a similar thing to the thing I did. So it's quite often done with other keynotes for large brand names as well, when they trim together the better shiny, and they see Steve Jobs or whoever now on stage talking about Apple products, for example. So it is done. Do they use Transcribe? I don't know. Could they? Absolutely. This architecture could be used for that. So we'll have to see. We should probably start to do it now. I'll start a community and we'll do it, and we'll advance this forward.
Okay, thank you, Mike. Let me check if we have any other questions. Yes, one more question from Philip. Is it possible to replace Elemental Media Convert with Lambda with FFmpeg, EFS, S3, and step functions? Okay, good question. So maybe there's all kinds of things you can do, and the question then is, should you do it? So we can use libraries like FFmpeg to process video. We could probably use it to edit video. Yes. EFS there, which you're talking about, so that's the Elastic File Service. That's basically an NFS file store. So we could use it to store files that we could use in the editing process. You could link it into your Lambda function. So yes, S3 obviously we've already used in step functions to coordinate it. So yes to all of those things. The question is really, in my mind, is to whether that's what you want to do, because that's going to be a fairly complex function that you're going to put together in Lambda. Now, Lambda's got limits. It's got memory limits, it's got processing limits, and it's got time limits. So it's limited to a 15-minute execution. Now, in this particular case, that could be okay, because the whole thing takes 15 minutes to run, and most of that's spent up with Transcribe. So yes, probably. Are you going to have enough memory? Maybe, yes, probably as well. But it's the code base that you're going to have to manage yourself in that case. Now, all of my Lambda functions in this solution are simple. And with the sort of serious conversation about serverless architectures, keep your Lambda functions simple, keep them doing simple little jobs. Media conversion is typically one of those things that we immediately say that's probably too far for a Lambda function. If you're converting an image into a thumbnail, that's one thing, but transcribing and transcoding and editing a 2.5-hour video is beyond what you'd naturally think a Lambda function should do. So when Elemental Media Convert exists in the world, it makes sense to me to use it. Now, if there's cost implications, then there's always edge cases where you could say do something else. But in this particular case, I would say do that. If Elemental Media Convert doesn't do what you need, probably the best thing to do is put a Docker container together with libraries that work in that way. Okay, thank you, Mike. I think we have one more question. It's from, and I will read out the question. Can we use the same for the voice over or translation too?
You could absolutely extend this out. So I'd have to look into exactly how Elemental Media Convert works, but I'm sure there's a way we could do this. So there are other services inside of the AWS AI service layer that we looked at. One of them is Translate. So I've had a lot of fun with this in the past, putting architectures together where we can throw in a video, get it to do we do a transcribe, throw the transcription into Translate, translates it into a different language, and we could do subtitles. You can also generate text to speech with services in that layer as well. And so that speech file you could potentially overlay on the top of the video. There'd be a little bit of orchestration to do, but that could be a brilliant project. I want to work on that project. Reach out to me.
Thank you, Mike. We have a few more questions from our community. Okay, one question from the attendee. Can we search different words and sentences together?
Yeah, so absolutely. So when you looked at the transcription that we had coming out of the video, the first part of the transcription was the entire text. And so if we wanted to do analysis where we're looking for example, sentiment analysis on sentence structure, or if we just wanted to get sentences out, then we could relatively easily pass that massive string of data and just look for the delimiter of a full stop, for example. And if we did that, then we'd be able to get sentence structures out. We'd then have a bit of maths to do to figure out the timing for it. Actually, potentially, rather than tearing apart that initial string, we could just iteratively loop through each word that's in the transcription section at the bottom and start gather them all together until you hit a full stop. That's a sentence. Then do it again. That's another sentence. I've actually worked on a slightly more serious project using that technique to automatically create subtitles. So yeah, you can absolutely do that. Now, once you've got the text once you've got the speech of the video in text format, the world is your oyster. You can kind of do whatever you want.
Okay, thank you, Mike. The next question is, can we extend the same concept to edit a video by the presence of an image in it?
You forgot to say that at the beginning it says cool demo. But anyway, thank you for saying it's a cool demo. So could you do it by looking for the presence of an image in it? Yes, you could. So there are other services that we haven't looked at. Rekognition is one of those. So Rekognition with a K. There is the ability for the Rekognition service to analyze streaming video. It could look for the presence of various imagery within the video and edit it together like that. Yes, starting to get a little bit more complicated and a little bit more costly, but could absolutely be done.
Thank you, Mike. Next question. Can it detect two different words that may not be necessarily used together?
So maybe that's talking, in relation to the simple demonstration, I guess we've done here, as we've just pulled out the one word. We could absolutely extend it, as I say, to sentences or to two different words. So you could say, I want to edit the same video together with the top 5 adjectives used, if you wanted to do that. So again, once you've got the text of the video, you can process it as ever you want. The only limitation I will say is that Elemental Media Convert in a single job has a limit of 99, I think it's 99 or 100, 99 video clips that you can edit together, or 99 clips that you can take from a single video. So if you did go and have more clips than that, you'd have to probably chain these things together somehow. But other than that, yeah, absolutely, you can extend this out to more words.
The next question. And his question is regarding the machine learning models, linear, Paston, SVM, factorization machine, CNN, etc., and the implementation in Python. What is the best book or resource to learn about parameters and algorithms?
Okay, so great question. Because I got a great answer, and it's going to be entirely self-serving, but there are other answers too. So you're asking about a level of machine learning going beyond these AI services. We're going down really to the next level of the machine learning services, which are inside of AWS, predominantly in this SageMaker area. So that's where we have the different kinds of models exposed. So at the top level that we've been playing with today, these types of models are behind the scenes. We don't really need to know what it's doing. It can sometimes be interesting, but much in the same way with other AWS services, I don't need to know about the service infrastructure that holds S3 objects. Sometimes interesting, but I don't need to know. But going down to SageMaker level, this is where we expose this kind of thing out. So we can look at the different kinds of models you've got there. Linear models, you're talking there about deep learning models with neural networks, SVMs, and all that kind of stuff, or convolutional neural networks you've got there as well. Yes, you can do that in AWS. You do it in SageMaker, or that's certainly the first place you'll do it. You can do it in other places too, but SageMaker is sort of like the place you'd naturally go to. You can absolutely implement it in Python using SageMaker notebooks or the SageMaker Studio IDE as well. So you can put this all together in there. In terms of resources that you can use to learn this stuff, well, I put the link up to my course before. I don't know, maybe I should do it again. So I have my course, which is targeted at people really to help them pass the machine learning specialty certification. But the first half of it, which is really the half that we've really got to grips with so far in this early access preview, because it's still being made, it really does go through the fundamentals of machine learning. So we go and talk about what is linear regression. Well, actually, we start off before that. What is machine learning? Like, what is it? Like, what do we use it for? Then we talk about what is linear regression, what is logistic regression, and we go on and we talk about convolutional neural networks and how they're used and how we measure them and all this kind of stuff. It's my passion. I'm really super excited about it, which is why I could talk about it for a long time. But I don't know, maybe if I put up my slide one more time, here. I don't know if it's possible for you to put this up, but the link is at the top of the screen. So link.mls-c01, which is the course, the certification code.com. Apart from that, there are some great SageMaker books out there as well. Get in touch with me on LinkedIn. So my address is on the bottom there. Get in touch with me on LinkedIn. I can share some resources. There are some AWS solution architects that have written books as well that I can point in the direction of. So yeah, there's a wealth of resources out there, and yeah, I'd love to help you out.
Thank you, Mike, for the wonderful insight. I hope all you enjoyed the session as well. If there is any additional questions from the attendees, Mike, we will pass it to you. Please log into YouTube and you can directly comment there as well. Thank you.
Absolutely. Thank you so much.
Ladies and gentlemen, this is a lunch break now. We will resume here at 2 p.m. However, the second quiz will be online from 1:30 p.m. Please try to play the game and stand a chance to win goodies. Please be on a time as we have a lot more to cover. Thank you. Hi everyone. Quiz competition is still going on. Link is available in the description. Please log in with your registered email address and play the game to win Amazon vouchers. I will make a quick walkthrough through our afternoon sessions. First, we have Mind Touch on serverless cron with second level schedule and conditional flow. For the fifth talk, we have Vijay Nirmala for Unicorn, leverage and accelerate CI/CD for the databases using AWS native tools. For the final session, we have a talk on linear TV broadcast playout, on-demand disaster recovery by Vijay Sagar Vinakota and Arbit Malani. We will resume here at 2 p.m. See you at 2. Stay tuned. Thank you. Hope you all had your lunch. Welcome back to our afternoon sessions, and the result for the quiz will be announced at the end of our community day. Let's dive into next session. Let me introduce Mind Raj. He is solution architect at Cactus Labs. Mind is a solution architect with a knack for architecting and developing large-scale systems that take advantage of artificial intelligence, machine learning. Being an avid advocate for everything serverless, he is also very active in the open source communities. Mine will be talking about serverless cron with second level schedule and conditional flow. Welcome Mine to AWS Community Day. Over to you.
Thank you. Thank you so much for that great introduction. So hi everyone, I'm Mayank Raj, and as it was said, I'm a solutions architect and I work with Cactus Labs. I'll not dive into the session itself. So let me set some expectations that you should have from this session. First, we will talk about the approach to serverless computing. So we'll talk about the why and how behind serverless computing. And how it gives you more flexibility, and then compare it against a set of metrics that we will look at soon. Now, these set of metrics are not tied into just serverless computing. These would be things that you would try and answer or benchmark against for any kind of solution that you're coming up with. And just like it, we will also try and benchmark the solution that we propose in this particular session against these metrics. To make everything relatable, we will look at the implementation of cron and try to re-architect or reorganize cron so that it's relatable to you. So in essence, we will break down a fairly typical component of almost all systems, which is cron, something that you might already be familiar with, and use that as a case study to discuss the pros and cons of serverless computing. So with that, this is the only slide which talks about what serverless is, and maybe the only thing that you would ever want to know is that serverless is one of those ideologies wherein all that you provide is the business logic and the execution constraints under which that business logic has to operate in. And everything else is taken care of by the provider for you, in this case, AWS. It scales on demand and in seconds. In many cases, it is already scaled up to accommodate for 10 times, 100 times the load that you're already experiencing. So the scaling is really quick. And the most important thing, you pay only for the actual usage. So there's no payment that you have to make for idle capacity. So unlike something with on-premise servers where you would have to pay for the capacity itself, cloud computing was a big boost wherein you now start provisioning stuff only when you need it. Serverless takes that to a whole new level wherein you don't even have to provision anything, but you only use the capacity and pay for just that. And finally, serverless on AWS makes more sense because it now has deeper integration with various other AWS services. Like for example, your logs are automatically bundled up and sent to CloudWatch. Your tracing is already enabled via a few clicks when you start using X-Ray. Your administrations or your access policies are already governed by services like IAM. So everything is very tightly integrated into each other, which makes it all the more easy to start leveraging this practice. So a small introduction on what cron is for those of you who are not familiar with it. And before we get into the interesting part, let's look at what cron is. So cron is nothing but a time-based job scheduler. At its core, it's something as simple as that. You provide in the time, you provide in the pattern in which you want certain jobs to be triggered, and you provide the jobs that are to be triggered itself. So you essentially, for example, you would say that every Monday at 8 a.m., trigger a job that sends out weekly email updates. And the cron service will take care of the rest. The important thing to note over here is that the job itself is not a part of cron. It's something that is maintained outside the ecosystem of cron or outside the service limit of the cron service itself. The only thing that cron is concerned with is the pattern that you supply or the time base that you supply and the job that it has to trigger and everything else is taken care of by the cron itself. Now, so yes, let me address by saying that serverless is indeed everywhere. And you will find many talks, many white papers, and many case studies that show how serverless is can be implemented in any of the architecture that you might think of. And there's a good reason for that. There are clear benefits of using serverless, and in many cases, it's the best option to go for. But as we will discuss later on, it's just another tool. It's just another way of architecting systems, and not really something that you should always that and not really a one-size-fits-all solution wherein every system can be architected in the serverless ecosystem. You have to be very careful about the constraints of the services that you're using, and then design around it. So before we even get started, you might say that, wait a minute, serverless cron, really, is that not a bit of overkill when it comes to re-architecting or reinventing the wheel? And to that, I would say yes, it obviously is. But there are good reasons why this might make sense. One of the very first thing is it's a good starting point. Not much can go wrong here. You can knock it off in a couple of days or in a couple of hours. And more importantly, cron is already a process that is decoupled from your stack by the sheer nature of it. So it can be a relatively simple switch when you look at it. It's one less thing to manage, maintain, monitor, scale. When things go down, you have to actually go back, debug what is the core issue, and you find out that the services that cron was actually utilizing down the stream is where the actual problem lies, and not really with the cron itself. So there are those things that you don't have to worry about in this scenario. It's really decoupled from your system. And as I said, it's one more thing or one more component of your system that is truly decoupled. So one more component that you don't really have to pay attention to. And finally, serverless is cool. It is something that is really catching up, and it would really help you if you start looking into things from this perspective. So my goal with this session with the next couple of minutes would be to help you see and reason for serverless computing, help you see how serverless makes sense in a certain ecosystem and how to reason for it. If there's one thing that I would want you to take away from this, is that apart from looking at how to implement a serverless cron itself, is to also see how to reason for these kind of implementations in the very first place. So yeah, take away why more importantly than the how of the talk. So let's start with an example, and you might have already guessed looking at the title of this session. We will not only re-architect cron to be in a serverless environment, but also add another knob to the system, which is seconds. So traditionally, if you wanted to go granular than a minute with cron, you would do something like adding sleep between multiple commands. So you would start with something wherein your cron service triggers a job at every minute level interval, because that's the most granular that it can go. And if you wanted to go beyond it, you would add sleep. So the time from when the cron actually triggers that script to the time when your script is actually triggered, your system is actually waiting in between. And that's not really ideal. That's not really how things should be functioning. If things fail, there's no good way to be alerted about it. So we'll go from having minutes, hour, month, day of week, and command, which is the general syntax of cron, and add the second level prefix to it. So we'll start. So this is how eventually a cron command would look like. So the metrics, this is what I talked about of how you should reason every serverless or any kind of architecture for that matter. And these, as I said, these are not just for serverless. So we will try and see the solution that we come up with. How do they compare against these metrics? So we'll start with reliability. Can you actually set it up and forget about it, and never be concerned about its functioning or maintenance in the long run, without being alerted only when you have to be alerted? So when things are going wrong, that is the only time when you go back and look into what is happening in the system. We will also see for scalability. So we'll see if the system is agnostic to the event of triggering just one function versus triggering hundreds and thousands of functions. And what is the role that you have to play to actually achieve this level of scalability in the system, and what are the various trade-offs that you have to make. Does your maintainability go up as the system scales up? Does your cost go up as your system scales up? Is it difficult to manage the overall system if it scales up? So we will try and talk about all that. We will also talk about maintainability. It ties in very well with the previous 2 points of reliability and scalability. Does the maintenance overhead increase as the size of the system increases? And more importantly, how do we leverage the shared responsibility model with AWS? Right, one of the things that made cloud computing so popular is that unlike the traditional times, you are now sharing the responsibility of maintaining an infrastructure with someone who specializes in doing that. So we already have seen, and cloud computing is a living example of that shared responsibility model in the long run really plays well. So we want to see if we can give an even greater piece of pie to AWS or for experts to manage, and be really only concerned with the customizations that we have to build on top of it. So only be concerned with the business logic that we have to implement, and the various services like Fargate or are examples of just that, wherein all you say that this is the code that I have, and as we will see, Lambda are example of that as well. This is the code that I have. This is the condition in which I want to run this. Can you manage the instances itself? As discussed, we will also look at adding how we compare against the second level resolution. So does that make things even more difficult to go from, say, just 1 minute triggers to having triggers every second or every couple of seconds, or a specific pattern? Say I want trigger at the 10th second, I want another trigger to not happen at the next 10th second, but rather happen at the 40th second, so on and so forth. We will also try and look for cost. Cost is one of the most important things, and arguably the top 2 or top 3 important parameters when it comes to designing any kind of architecture. And low cost in a great deal also means that your system is optimized for operation. You're not spending your money in places where you don't have to spend it. You're optimizing the use of your cash. So we will look at does the cost of the raw infrastructure goes down itself or not. That also means there's a measure of cost that can't be really measured in traditional sense, which is the cost of maintainability. Does the manpower or the human hours that go in maintaining that system go up or down? And that, according to me at least, is a much larger cost when compared to infrastructure cost. But over here, we will look at the infrastructure cost itself. And finally, debugging. If whatever architecture that you're proposing disrupts the development workflow or disrupts any kind of development for that matter, then it really doesn't make sense. So we will see how it measures against the traditional development workflow. Can we debug stuff when it breaks? Do we have enough logs? Do we have alerts set up? And more importantly, what is the effort that goes into setting all of these up? So we'll look at, let's be real, we'll look at if we get more and more, as much log as possible. So we started with this sentence, cron being a time-based job scheduler. And now let's start designing architecture or plugging in services to satisfy this condition. So our first point or the first metric or the first feature that we have to cater to is time-based. So there should be something that can generate events or trigger certain pieces of the ecosystem with a given pattern of time, and it should be periodic and have a predictable pattern. So we will use this service called EventBridge for that, and to be more specific, we will use EventBridge events. It's a replacement or a superset of what CloudWatt Events was a couple of months ago. And EventBridge is this new service released by AWS, which again is a managed AWS service. It's serverless, and to be more precise, it's serverless event bus that can deliver stream of real-time data and collect it from various sources on one end and deliver it to many sources on the other end. And you can form complex logic on depending on what kind of sources you're receiving events from, and what kind of sources do you want to actually deliver the events to. And these, and most importantly, these sources don't have to be just internal sources. So don't really have to be application hosted within your AWS environment. It can be external sources as well, and not just external AWS accounts or your other AWS account in your organization, but also other sources like Zendesk, Datadog, PagerDuty, for example. So you can set up very complex things like if a new ticket is raised in Zendesk, or if a new alert comes in PagerDuty, instead of polling these services again and again, or making use of webhook, actually develop a real-time event stream wherein these trigger various processes within your application itself, and they enable you to build event-driven architectures, which is far better than polling architecture in most of the cases. So the next part is we need something that can schedule jobs, or that can schedule various processes within our application. And for that, we will use step functions. There was a great introduction of step function given a couple of sessions ago, but I'll try and quickly reintroduce it. Wherein step function is a serverless orchestration. It gives you way to orchestrate various microservices within your application, and abstract away the microservices or the logic of triggering these microservices out of the services themselves. And it does so in a serverless fashion. As a very bare bones examples, if you have set of Lambda functions, the output from which has to go into another Lambda function. Before something like step function, you would use something like SQS in between Lambda functions. So each Lambda function would write its output into a particular SQS queue that would trigger the next function, so on and so forth. Your logic of actually which queue to use, which in turn controls which next Lambda function will be triggered, was within the previous or the governing Lambda function itself, which is not really good. Your logic is separate or is bundled into your core application itself, and that is where step functions come in. In this example, this is and it also has a visual interface, which is what you see on the right over here. In this example, you start with a particular event, and step function takes care of bundling that event, triggering a Lambda function with that particular event, taking the output from that particular Lambda function and passing it to the next one in the loop. So in its simplest form, it lets you trigger a set of Lambda function, take output from one of them and pass it to another one. More importantly, in between transitions, you can also add conditional flow. So as you see over here, there's a conditional flow saying that is the case resolved, and depending on what the output or what the evaluation of that is, you can take one of the two paths or one of the many paths. It doesn't have to be binary. So if a Lambda function A was successful, you can set up something like if it was successful, trigger the next one which actually acts on top of it. If not, trigger another one which actually handles the error. State machines, or step functions to be precise, also encapsulate the logic of error handling, retry logic and sequences within it. So if a particular Lambda function is failing, it will take care of retrying that Lambda function n number of times. And if it still fails, passing on those events or those messages in a separate queue for you to then debug at. Finally, we need a job itself that needs to be triggered, and this can be very specific to your business. This can be something like a webhook that is managed internally, or can be a Lambda function that you already have that was earlier triggered via AWS API calls from your cron service. So we will use Lambdas as an example, and then later on see what different jobs can also be used. A quick introduction to Lambda: it allows you to run code and specify just the code. So all that you do is say that, okay, hey, this is my code. It can be in one of the many languages natively supported, or even custom runtimes for languages that are not direct or not supported directly by Lambda. And you say, this is the constraint that I want to run this code within. So this is the memory size that it needs. This is the maximum timeout of that particular of the code that I'm supplying you with. And AWS then takes care of scaling that to whatever concurrency that you need. AWS also takes care of collecting logs from your function and passing them to CloudWatch. It also takes care of setting up alerts around it. So if you're experiencing a lot of errors within your function itself, it will try and retry those messages again and again. And if not, it will drop the concurrency of your function so that you're not paying for failed jobs in the long run. And the most important thing, you only pay for when your code is actually running, not for having a Lambda function. So the only cost that you pay is actually for the amount of time your Lambda function ran. And it's actually a function of just your execution time and the memory that you allocate to your function. Just that. If you don't trigger your function and you have thousands of functions in your account, you will not be paying for them directly. Okay, so this is how you tie all of these three services together. You have your event bridge, which is triggering events at a set interval. Now, in this case, because we want to go sub-second, we trigger it at every minute level interval. That then flows into step functions. And as we that are triggered at various intervals. In this case, it's been triggered at 0th second, at 15th second, is the same Lambda function but triggered in a different environment. So you can control with step function what inputs are actually passed on to each of these functions, and they know that in which order they are actually being triggered. So with this, let's go back to the metrics that we started with and see how is the architecture performing against these metrics. Yeah. So we will start with the first three and arguably the most important, which is the reliability, scalability, and the maintainability of this system. So we are making use of managed services all the way. So Event Bridge, a managed service. So is the step function and the Lambda functions themselves. So you automatically are abstracted away from the core management of the infrastructure itself. You automatically build this architecture with decoupled components. So no two part of the component are directly or have a heavy dependency on the previous part. If a particular Lambda function fails, the next invocation of the Lambda function, although it will be using the same code, will be in a different set of environment, which is isolated from the other one. So you automatically have non-dependent layers baked into your system. It's easy to replace one without affecting everything else. And that comes as an advantage with any of the decoupled system. You can just, if something is not working well, instead of trying to figure out why it is not working, you can just replace it with a new instance of that particular microservice, and then try and debug on the sides why the issue came up in the first place. And this also brings us to the point that failure never propagates. So if your event bridge is failing, or if there's some issue that came up with event bridge, you can still find a way to trigger step functions directly, so that the failure of event bridge doesn't impact the other parts of the system themselves. And finally, the use of Lambda function gives us n number of flexibility. So we just discussed most of these when we were discussing about, when we were introducing Lambda functions. But few of the things that I would like to point out is that Lambda functions themselves can also retry failed jobs. There's also this concept of having Lambda dead letter queues, wherein if your function is failing or if your code is failing after n number of retries, it can automatically push them into a SQS queue, which you can be alerted of whenever there's any new message in that queue, and you can start debugging why the failure came up in the first place. very complex condition, because all you get the flexibility of passing in your own code. You can come up with very complex condition that is actually triggered within the Lambda function itself. Few of the very neat features of Lambda is that it also provides versioning. So you can have multiple versions that test or the beta, alpha, as well as the version of the code that is in user acceptance, and the version of the code that is in the canary deployment within the Lambda function itself. So it gives you various flexibilities around the deployment of the new code as well. You can set up Lambda function to actually do stage deployment, and if you experience a certain number of errors within this new version, it can automatically roll back to the previous version. So all of those things are encapsulated into the service itself. And there's logging, CloudWatch alarms, X-ray tracing baked right into the service. So you don't actually, unlike say if you were having this particular function running in an EC2 instance, you don't really have to worry about bundling all the logs from your application. So using something like CloudWatch agent within your instance itself to bundle everything and send that to CloudWatch. All of those are done automatically by Lambda. There are alarms set already. So if you are experiencing X percentage of errors in your function, you can automatically be alarmed for it, and you don't have to do a lot of setup for that. Let's look at second level resolution. Given that we are using step functions to trigger our jobs, in this case a Lambda function, they can be configured to trigger them at any interval. We looked at an example where we were triggering it at every 15 seconds, but it can be very complex in terms of at the 5th second, at the 30th second, and at the 45th second. Doesn't have to follow a very specific pattern. It can also be dynamic. It doesn't have to be just on time, unlike cron, wherein you can now add your business logic into it. So you can say that if my mean response time of a particular application rises above a certain threshold, trigger an alert, and then every 5 minutes trigger a health check. So you can build complex logic on top of it by using step functions. If you look at the cost, as we discussed, we will look at the raw infrastructure cost itself. So if you have a Lambda function that has that will be running for 10 seconds with the given memory for every 30 seconds for 30 days straight, you would end up paying just $4.3 for every 30 days period. Which if you compare to traditional services, it's a lot cheaper than that. And this is the cost of the raw infrastructure itself. Mind you, if you were triggering this or setting this up in a EC2 instance, there would also be things like what if the EC2 instance goes down? What if there's an instance failure? How do you set up or aggregate logs? And all of those things are automatically taken care of. So this is just the cost of the raw infrastructure. And as you in general measure, if the cost of raw infrastructure goes down, your manageability also in general goes down. And finally, metrics, or finally the debugging metric, right? It's one of the, if everything else is working out, but if it becomes difficult to develop the application itself, then that architecture itself doesn't make sense. So you want to have detailed logs available at every point at every point. You want to have alerts set up directly so that you are only notified when things go wrong, and that is the only time you actually get back into the system and see what is happening in it. You also want to have retry logics, or you already get retry logic as the service offering with step functions, with Lambda in form of dead letter queues, etc. And as you can see over here, you get visual interface of what earlier was just code. So as you can see in this example, it's just the visual interface that the step function will provide. So you have your starting point, and then you have Lambda functions triggered at every 15 seconds interval. And most importantly, this gives you a lot of interesting use cases to build or architect the systems around. You unlock a whole new level of applications that you can build on top of this and around this. All of this comes with the fact that instead of working with the low-level services directly, now you're working on a much more abstract level of managed services. and you're automatically gaining the advantage of the new services or the new features that are rolled out by AWS. Like for example, AWS recently rolled out Lambda functions having access to file systems directly, something that was missing earlier, and that now enables you to have more than 512 megabytes of memory in the Lambda function itself. It also allows you to now start using database proxies directly via the interface in a very easy format. So all of these are developments that are happening at a much higher pace with managed services, you can automatically start leveraging them. So let's look at few examples in which you could expand this particular ecosystem. So we look at wherein we started with EventBridge on the left. We have step functions that actually orchestrate the Lambda functions themselves. And as we talked about, all of them are decoupled from each other, which means that EventBridge function independently of the step functions, and so does Lambda function independently of the step functions themselves. And all of these can be triggered independently of each other. So there's nothing stopping you from taking the events coming out of EventBridge and actually fanning them out to multiple services. So it doesn't only have to trigger a step function, but now your core service could be extended to also send an email while this triggering has happened. So you could also send an email in the example that we looked at earlier. Instead of just sending an email of weekly report on every Monday, you could send one right when the job is starting and say that you will receive your weekly report in the next 1 or 2 hours or whatever time the jobs take. So you can build complex logics around it. Similarly, step function can just triggering of these Lambda functions. As we already have discussed, it can have complex business logics encapsulated within it in the first place. Similarly, now we can also start looking into benefiting from the feature sets provided by these services by themselves. So, for example, we talked about EventBridge being not just a way to trigger events, but also something that can manage events or help us in building decoupled system. So the trigger for EventBridge can come in from internal as well as external events, and can be also cross-account event. So, for example, instead of having a cron that queries, say for example, Shopify API every 5 minutes and say, give me any new orders that have come in the last 5 minutes. You can now make use of the direct integration that Shopify has with EventBridge, and you can be notified of any new orders that come in directly. So you can move from having a pull-based system or start with a polling-based system and eventually gradually move over to a push-based system without disturbing anything else. So you are not disturbing anything else, but you're actually only triggering events or triggering these jobs when you actually know there's something to be pulled out. Similarly, if you look at the right, we are using step functions as a way to orchestrate our jobs. And as we discussed, step function can't only trigger Lambda function, but can trigger host of various other AWS services as well. So you can leverage the fact that step function can trigger these services directly to build very interesting applications around them. So your cron can instead of having a cron which would traditionally use tons of AWS API calls and try and maintain or orchestrate jobs between these various services by the step function itself. So you could have something like a weekly EMR job that is triggered, and if your job actually fails, step function can also do the task of retrying that jobs and alerting you that something is failing. You need to come back and look at it. Finally, given that everything is now decoupled, stopping anything doesn't affect the other parts of the ecosystem. So if you want to stop the processing at any point in time, you can just stop the events being generated at the EventBridge level, and be rest assured that everything else will just pause. To add to it, given that you're using serverless services, so you're using services wherein you pay only for the time that you actually use them. In most of the cases, you'll actually also don't have to really work upon stopping those services directly. So in a traditional system, you would, apart from stopping the cron service itself, you would also have to go back and stop those EC2 instances or hibernate those EC2 instances. And when you had to start it up again, start services on those EC2 instances, for example. Over here, you just stop your events being generated at Event Bridge and everything else is taken care of. And finally, one last thing. We looked at one of the constraints that we started with, or one of the feature set that we wanted to account for, is to also have second level schedules. If you don't want that, if you just want to replace cron in your existing system with this new service, you can simply take the events from the event bridge and route them directly to your job or to the Lambda function. And given that a huge chunk of our cost of those close to $4 were coming in from the state machine in between, this will cost you not more than 6 cents for every 30 days for the same level of for the same number of triggers of the Lambda function itself. So this comes in really cheap, and again you're leveraging the same fact that you're starting with serverless services throughout your ecosystem, and have the flexibility of also using various other services provided or various other functionalities provided by these services themselves. And start with a pull-based system and eventually move down to a push-based ecosystem. And with that, I would like to end this and with on one very important note. As I started with serverless, you should treat serverless as just another mechanism. It's very good in certain use cases and really bad for in cases where you don't account for it. You need to know the limits of the services that you're actually operating with. For example, Lambda function can't be used in any and every scenario. There are certain limitations when it comes to Lambda function, like it can't run beyond 15 minutes. So if your job is actually going or is expected to run beyond 15 minutes, and you can't break it into multiple smaller jobs, then Lambda is not a good fit for it. Similarly, this very popular serverless API gateway, serverless tool API gateway, has the limit of having 29 seconds hard limit on the timeout. So if your API doesn't conform to those specifications, serverless can become a real pain to manage in the long run. So you should always treat serverless as just another tool in your tool belt, and try to bring it up, or in cases where it actually makes sense, and in cases where it will actually simplify a lot of management over it. So with that, I would like to open the floor for any Q&A or any questions that I can answer.
Thank you, Mike. Now let's have a quick look whether we have any questions from the audience. Yes, we have a first question. How about Fargate and Lambda, both in step function?
So yeah, you can absolutely do that. You can have Fargate services or Fargate tasks being triggered from the step function directly, and it doesn't have to be one or the other. It can be both of them at the very same time, wherein your step functions can trigger the Fargate services as well as Lambda functions.
Thank you, Mike. Let me check if we have any more. Okay, the next question from Vinay. What happens if Lambda function take more than the time shown in the slide? 0, 50 seconds, 30 seconds, 45 seconds?
Absolutely, that's a very good question. And the way that serverless functions operate in general is that they're independent or in actually functioning of each other, which means that the Lambda function that is triggered at the 0th second is triggering in its independent system than the Lambda function that triggered at 15th second. So even if the first one takes the whole chunk of 15 minutes, which is the higher limit of Lambda functions, the other one would still be triggered in parallel at the 15th, 30th, and 45th second. So you're automatically abstracted away from having to manage this concurrency on your end. And Lambda function can do that on your behalf.
Thank you, Mike. The next question. How can I run cron written in PHP code as Lambda function?
Right. So cron by itself is just a trigger. So you can have and your code, the business logic which is I'm guessing is what is meant by the PHP code, can be added to Lambda function directly. So you can have your PHP code run within your Lambda function, and that being triggered by the combination of event bridge and the step functions that we just talked about.
Thank you, Mike. Let me check if we have any more questions. Next question from Vikas. He's just asking about event bridge failing. You know, we need to plan for AWS service failing. How frequently is that?
Services. So one of the very core principle, or when you're working with any kind of service for that matter, is that you have to start with the assumption that things will fail. It's very infrequent now. I've rarely seen a AZ go down or a service go down, but there's a very good possibility for that happening. And if you read any of the white papers around architecting with AWS, or read or talk to anyone who's working with AWS or any tech in general, they will say that always account for services failing. In this particular case, EventBridge, you can look up at the SLAs provided for these various services. EventBridge is distributed across various AZs, so you're automatically abstracted away from that. But it's the same thing, right? Say for example, S3 gives this durability of having your objects replicated across 3 AZs. What if the whole AZ goes down, or what if that whole continent goes down, or the data center is cut off completely? So you have to always build around with the assumption that services will fail. But in grand scheme of things, that is very infrequent as of now.
Next question. Can step function create 100 new lambdas and destroy when it is done work?
Right. Step functions, there's virtually no limit to how many Lambda functions you can create. In our production AWS environment, we have the concurrency set to 20,000 functions. And that is still a lower limit in one of the AWS region, which means that you can have 20,000, 30,000 Lambda functions running in parallel at the same time. And step function can just orchestrate them.
Thank you, Mike. Let me check if we have any more questions.
Yeah, that's a very good. Again, Glue is does have a direct, from what I remember, does have a direct integration with step function itself. But step function also provides this neat trick of wherein it will give you with a access code, or with a particular key, which is what is called as a manual loop. So you can reply back whenever you are done with your processing. You can actually reply back saying that I'm done with my processing, and this is actually used for manual loops. So even if any of the AWS service, or even your on-premise service is not supported natively with step function, you can always make use of these kind of manual loops, which can, or I should not say manual, automated loops, wherein you make an API call and say step function that, okay, my job is done, and you can proceed to the next step.
Thank you, Mike.
Yeah.
I think we have more questions coming. The next question, is it possible to shut down EC2 after 50 minutes of idleness of EC2 with step function?
Yes, you can absolutely do that, but a much better way to go about it is, as soon as you detect idleness, you can use a combination of CloudWatch and Lambda functions directly. So CloudWatch alarms and Lambda function to actually shut them down. Step function would be an overkill in that case, and just as I talked about, is not a one size fits all. So you can have a cron job that actually triggers and checks EC2 instances at every point in time, or at regular intervals, to see if it is actually up and running and it is actually being used. But a much better way around to achieve this would be use a combination of CloudWatch and Lambda functions.
Thank you, Mike. We have a few questions from our community. And the first one is, we would like to know about the first AWS service that you have used.
Interesting. So my first AWS service was actually Redshift, and it was one of the big data application that we were developing, and we were looking. That was the time when I was looking into what is the best big data application, and at that point in time, All of these other services came with a huge licensing cost and this huge learning curve in them. And I actually stumbled upon across Redshift and found it that to be very easy to set up, even at a very large scale, and actually grow from very tiny application to a very huge application.
Thank you, Mike. We would like to know about your DevOps journey so far.
Okay, so I started as I said with that big data application with Redshift, and today I mostly develop large scale distributed systems, which is just a fancy way of saying that I develop systems that can scale very well. I have had the opportunity of working on few cutting edge things like we were one of the very first customer for few of the AWS services that were released and actually started working around them. So we have actually worked, or I have actually gotten the opportunity to work very closely with AWS service teams in general. And apart from that, I'm a big, as was mentioned in my introduction, I'm a big advocate for serverless, for toolings like CDK, and actually very active on those communities as well.
Thank you, Mike. We have one more question. Tell us about the biggest challenge you faced in configuring serverless environments.
So the biggest challenge is always to know about the service limits themselves. So when I was first introduced to API Gateway, I designed this whole system of using API Gateway triggering very complex set of Lambda functions, DynamoDB directly from the API Gateway. And later on, when I started looking into the service limit of API Gateway, realized that it has this service limit of 29 seconds, which actually was a big problem for that application, and actually meant that I had to start from ground up and work along that. So one of the biggest takeaway for me is to always know what is to be used and always know the constraints under which it has to be actually developed and then work from there.
We have one more question from our attendees. That's from Philip. Can you please tell us about the Lambda-verse functions as service in Kubernetes?
So it's to a great extent there is a overlap between the two, even with Kubernetes. But the only problem with Kubernetes is or the functions as a service in Kubernetes is that you still have to manage the Kubernetes cluster, right? Although you get the flexibility of having Lambda or having functions run inside them, you are still the one managing those clusters. Even if you're offloading that to and using a managed Kubernetes service, there is some level of management overhead that you have. The benefit of using Lambda function is that the other parts of the ecosystem within AWS are very tightly integrated with Lambda. Lambda is one of those services which I'm assuming if whenever AWS service team is coming up with new services and they don't know or they think about how do we add customizable option to this, they always stick with Lambda function over there. So it is one service that is present as a customization option throughout the AWS ecosystem. We talked about step functions. It can be triggered by SNS. It can be triggered by API gateway, so on and so forth. So there are various integrations around Lambda function, which actually makes it a more compelling options against functions as a service in Kubernetes.
We have one question from our community. Any recommendation for the new minds in serverless world and how to get it started?
Sorry, can you repeat?
Yes, any recommendation for the new minds to get into the serverless world? Any suggestions to get started?
Sure. So I would recommend start very small. And there are various good tutorials around Lambda functions and using a combination of Lambdas, SQS. There are also various abstraction that AWS has done a very good job of coming up with these abstraction. Like you have AWS SAM, AWS CDK, and even the very recent Amplify, which actually abstract building serverless or provisioning this serverless infrastructure on top of AWS. So you can start over there. You can set up a very complex working API in a matter of couple of minutes, and then look into how things are functioning from there. So use something like SAM, one of the pre-built template with AWS SAM, which is serverless application module, or AWS Amplify, set up an application and then go back and see how those applications are actually connected to each other, and then you'll be in a good place to actually see why is it using API gateway, why is it using CloudFront, or why is it using Lambda functions, and that can be a very good way to start go about it.
Thank you, Mayank, for the wonderful insight. I hope all of you enjoyed the sessions as well. If there is any additional question from the attendees, Mayank, we will pass it to you. Please log into YouTube and you can directly comment there as well. Thank you.
Sure thing, absolutely, it's really fun. Thank you for having me, guys.
Alright, don't forget to share your feedback via Lanyard. Let's dive into our fifth technical session for today. Let me introduce Vijay Nirmala. Vijay Nirmala is an ardent learner, passionate about AWS Cloud and DevOps automation solutions. She is an active member and contributor to AWS User Group Chennai and an avid technical blogger. Vijaya will be talking about Unicorn, leverage and accelerate CI/CD for databases using AWS native tools. Welcome Vijaya to AWS Community Day. Over to you.
to the AWS Community Day India 2020 Virtual Edition. All to the AWS Community Day India 2020 Virtual Edition. I'm happy and equally excited to be part of this online conference. So today I'm here to present a topic on Unicon, leverage and accelerate CI/CD for databases using AWS native tools. So I'm Vijay Nirmala, a hybrid cloud implementation specialist from IBM. And this is about myself. I'm passionate about AWS cloud solutions, and I journal my cloud experiences in my very own blog, and I do write weekly articles about AWS features and other new introductions of features in AWS in my LinkedIn page. And then these are my LinkedIn and Twitter handles if you're interested. So let's get into the solution. So looking at the agenda, we will look into the current state of DB deployments and why we should be using CI/CD for databases. And we'll pick up a use case architecture with which we will come around the solution and see how it can be done. And the deployment pipeline evolution, how it all happens, and how do we use the AWS native tools, and how the solutions works inside the AWS native tools, and where all other services could be integrated, along with the complete detailed implementation walkthrough of the solutions. And finally, let's end up with an alternate choices that are available for implementations. Let's dive in. So these are the challenges and the reasons that we are currently facing. CI/CD is basically about continuously integrating every change that happens, for be it your databases or it could be your application code. And how do we validate those changes? That is where the CI comes into picture, which is continuous integration. And then about the earlier we capture the error or a misrepresented code in our source code repository, the earlier we'll be able to capture and arrest the problem, so that the deployments and the time to live is much easier, faster, better, and a qualified product is delivered to the production. That is the aim of following a CI/CD practice. And in order to do this practice for databases, we have lack of environment and configuration that are required to pull through of getting a new database environment, wherein we would need a backup or a snapshot to restore. We should be having the server and the configurations available in order to support that setup, and how we respond to the changes that are happening in the environment when all other teams are using one particular environment. Unless we are in cloud, it's difficult. And in case of any database deployments that is happening, and in case of any issues, we always do a fix forward or a rollback, meaning we take back the changes that we have applied, or we fix the changes that has caused any issues, and then we move forward. And apart from that, we also have the risk of applying the DB changes against the data in the database. So in case if I have run any DML scripts against my data, in case I have updated my data and that has ended up in a wrong way or unexpected way, then taking back those changes are also difficult. So with all these limitations, it was very difficult to implement the solutions before for databases at least. And now let's see a solution which can help us to implement it easily. So let's see the application architecture. This is a simple architecture which is having a web application server with Amazon RDS database as a backend. And the generic services, we are using AWS Secrets Manager and the KMS for encryption, and Amazon CloudWatch and CloudTrail for monitoring and logging purposes, and SNS for email notifications. So let's see the architecture that we have drafted for the RDS databases. The components that we'll be using here would be one web server and one Amazon RDS Aurora MySQL database. Notifications will be via AWS SNS, and alerts will be using ChatOps, and we will be integrating Slack here. Monitoring will be with AWS CloudWatch and CloudTrail as discussed before, and the native tools that will be used here are Code Build and Code Pipeline. In order to use the code build, we'll be creating our own Docker image, and then we'll be retaining the code in the S3 so that it is secure. This is the overall steps that is involved in implementing this architecture. First one would be, in any implementation or a CI/CD, we will be having a code that will be retained in some SQL or a text file. And this has to be uploaded into some source code repository, which could be AWS Code Commit, GitHub, or S3. And then we need an environment to run all this and apply these changes and test it whether the changes what we are applying is correct or not. For that, we'll be preparing an ECR image. In our case, we will be creating a MySQL client interactive tool based ECR image, and we'll be retaining it for later to be used with the code build. Code build service, which is allowing us to build, compile, build, run or test against any databases or any other applications. We'll be using the ECR image that we created, and we'll be using the RDS snapshots for our existing, which is taken from our existing databases, and these snapshots will be used for creating a temporary databases, and we'll be running the DB changes against these temporary databases that are created. So after restoration, we'll be applying the changes, and finally we'll integrate and notify on any mishappenings or even successful and failure notification will be sent via Slack and also through SMS email notifications. Finally, if everything is successful, we could either be deploying it in pre-prod or prod based on the manual approvals that is being given. So let's see in detail. So over here, like in any team, developers will be creating code and they'll be committing into the AWS Code Commit repository. It could be your GitHub or S3, as AWS Code Build supports many of the source providers. All this will be starting from the AWS code pipeline, and we'll also be having AWS Code Build here. Code Build is a fully managed continuous integration service that compiles source code. It runs tests and produces packages which are ready to deploy. In our case, we do not have any output to be deployed, but rather we have something to compile and execute so that we can validate the log files to test the integrity of the DB changes that we have created. And we also have code pipeline here. Pipeline is a fully managed continuous delivery service that helps you to automate your release pipelines for fast and reliable application and infrastructure updates. So this will help you to build, test, and deploy your releases in phases of deployment. Each of the action could be retained or captured in a stage, and that stage could be executed and the purpose can be achieved. Then finally, with AWS Code Build and Code Pipeline, we also have AWS RDS snapshots here. So let's see what a snapshot is. Basically, a snapshot is, by definition, it is a read-only static view of a database, and it is transactionally consistent with the source database as of the moment it is created. So from RDS perspective, Amazon RDS will create a storage volume snapshot of the DB instance. It will take a backup of the entire DB instance and not just the individual databases. So the disadvantage could be that since the snapshot includes the entire storage volume, the size of the files and the temp files will also add into the volume of the snapshot, and based on use case to use case, the restore time could be more compared to each of the size of the snapshots. So when you perform the restore operations to a point in time from a DB snapshot, what happens is a new DB instance is created, and then the database will also be created. So what happens for every restore, there is a new endpoint that is being created. It's not going to use the existing database's endpoint. That is the one best feature and something good about using Amazon RDS snapshots. And when it comes to notification and alerts, we have also included Slack over here. So this Slack integration is available as part of the AWS chatbot service, which allows us to easily and securely integrate multiple other services into this Slack channel. So with chatbot, we can receive notifications about operational events, security findings, or budget alerts. It will be just delivered into the group ID or the direct messages which we have been configured. So Slack, as we all know, is a workplace communication tool. It's a single place for messaging, and you can also share files, and also other utilities can be utilized from Slack. So either you can create a public or a private group channels and use the Slack, or we could use a single direct messages to a single person in the team. So by that way, we have integrated many of the key services into this architecture. So by starting with the code pipeline and the source as well, in the code build section, we will be having certain prerequisites over here as 1, 2, and 3. And finally, we'll be implementing the solutions, ending up with notifications. So let us see in detail what is available in the prerequisites 1, 2, and 3. To start with, as we discussed, we will be taking snapshots from our Amazon Aurora databases from the RDS, and these snapshots could either be taken manually or it could be automated. We can directly utilize from the console, or it could be retained in the S3 for backup purposes. And the second set of prerequisites is about creating the Docker image, which will have the essential software and tools that are required in order to apply the DB changes for our Amazon Aurora database or SQL query changes. So for that, we will be having an image, say suppose Amazon Linux, and on top of that, I'll be having the MySQL client interactive tool versions installed. And this image would be stored in the ECR repository and thus end up in having it in the registry. So later on, this will be used in the code build tool. And the third set of prerequisite is about configuring and setting up the notifications. As we discussed, we will be using the Slack messaging tool, and we will be integrating by creating a configuration in AWS ChatOps so that the notifications are sent to the Slack channel. And we will also be creating and configuring AWS SNS for email notifications for manual approval. Finally, when the solutions is either, even if it is working or if it is failing, the notifications will be given. So in case of a successful completion, we would then go ahead and deploy the same solutions into the production connection, or it could be from a different account. Then we could use the cross-account roles access and get the solutions implemented. Now let's see in detail about how all these solutions, or how this is all coming together. So this is about creating the RDS snapshots. As discussed, we could either be retaining it into create a snapshot, and then we could export it into S3, and later on use this ARN in order to be used while we are doing a restore of the databases. And this is a snapshot of how it is being stored in the S3 bucket, along with the database name. For example, here becomes the payroll, and I also have a couple of tables here for representation purpose, and it will be storing it in a Parquet format. It's quite 2 times faster and 6 times cheaper than any text format that could be stored in S3. Hence, it is storing it in a Parquet format. And this is a view of a snapshot that is directly manually taken based out of the database that is relying in the AWS RDS. And now let's come ahead and see how to set up and configure a ECR. Elastic Container Registry is ECR, and we will be creating a new repository here calling my RDS image repo, and we'll be this is the URI that is being generated and could be used later on. Thus, by creating a repository, as you could see, it could be it is encrypted via KMS. And now we'll go ahead and create an image and then tag it to the latest, and let's retain it here, and we can use this ARN in order to be used it in the code build service. So as discussed, if we get into the code build service, under the environment section, we have options where we can configure and select the ECR image that has to be used. So I go ahead and select it as a custom image, and I select Linux, and from Amazon ECR and from my ECR account, I can select the image I just created based on my necessities, and then I go ahead and pick the tag with which I would want to work. And this is how the ECR repo is integrated with the code build service. And next we'll see how to configure Slack in this AWS chatbot service. So first we'll have the Slack app deploy, and we have to create a new channel. Over here it is my RDS CI/CD is the channel that I have created. And later on, this channel will be integrated with the AWS chatbot Slack app. And after creating a channel, I go ahead and start adding users, as many users I would want with the valid email IDs, so that all the users under this channel are receiving the notifications. And finally, this is a snapshot of how the Slack channel is integrated inside the AWS chatbot. Basically, we'll be configuring a client which becomes our Slack here, and the Slack channel will be configured here along the client configuration. And this ARN can be used with the code pipeline service, so that on any build failures, we will be notified via Slack. Now let us set up the SNS notifications for manual approvals from code pipeline. So as we all know, this is a simple notification service based out of email. So on adding a valid email IDs, we will be getting an email link for confirmation of subscription. On confirming the subscription to a particular topic, this happens to be my RDS CI/CD notification topic here. On confirmation, the email ID subscribed here will be receiving alerts from the code pipeline job against which this topic is set up and configured. Now let's see how the AWS code pipeline is configured for notification rules. So there is a new concept in notification rules. This will allow, as you could see, it is a rule set up on a subscription to events that will happen within your resources. So when these events occurs, you will receive a notifications to the targets you designate. So if you could see here, there are events that will be triggered based on the notifications, and it is classified against 4 categories like action execution, stage execution, pipeline, and manual approval. So I have selected about failures and cancellations over here, or in this case, if an action is starting, then I have selected for notification. So these are the events that will be triggering a notification, and the target happens to be my Slack channel over here. So the target type would be chatbots Slack, and the ARN we just configured in the previous steps will be selected over here. So this is how a Slack is integrated for any of the activities in the code pipeline. I can even go ahead and say if a pipeline is starting, as of now, I have configured only for pipeline executions, failure and cancellations will be alerting an message in my Slack channel. So this is how we can configure and set up the Slack channel to, code pipeline to notify us through the Slack channel. So this is the notification name, and the setup is now complete. Now let's see how to run the AWS code pipeline for database related CI/CD. So this pipeline has been created just with 2 steps, which is one is about the source with which I'll be able to take and run and apply the changes to the database environment. And the next one is the code build, which is giving me the environment to compile and run my database code in order to validate the changes. So with just 2 steps, we'll be able to complete this implementation. And as such, we are not having any application or a package to deploy, and we do not have any servers, multiple servers to connect, copy, and deploy the solutions or the packages. We will not be using code deploy here. So just by using the source and the code build stage, we'll be able to complete the solution. And as you could see, it could be S3 as well. The source could be. And this is about the logs that is telling us about how the solution has shaped up. The log is explaining us about when the build has started and the identifiers or the runtime parameters and the restore activities that are happening here. And this is the successful state of the completion of code build. This is the build log. And this is the actual implementation walkthrough for a buildspec.yaml. So if you're new to buildspec.yaml, this is the build manifest, which will explain the actions that has to be performed completely. And without this file, the code build is incomplete, and it will not be able to produce any output or result as such by code build itself. So we need this buildspec.yaml. Here it is divided into many phases like a pre-build, build, and post-build. And again, beneath this, we will be placing the commands that we would want to apply, or we would want to see execute in the target environment. So the environment against where all these commands will be executed is our environment which we have already created via the ACR image, or it could be that you could directly select a managed image. It could be Ubuntu or your Amazon Linux, and later to that you can install the MySQL client interaction tools over here, and then go ahead and use it. If you have to omit the ECR option here, usage of ECR service over here, then you could manually do it in the pre-build section. It gets into the pre-build section because before the actual build process happens, we need all this code and the essential softwares to be readily available. So the first thing that happens here is in the pre-build phase, I'm checking about the AWS version. My image is having AWS CLI 2.x version, and this is required in order to run the AWS RDS restore commands. So that's why I'm checking the AWS version. And either I could be able to clone it from the repository. Over here, I have taking the repository from release 010000, or as an alternate idea, I could be copying uploading the code into S3, and from S3 I could copy it into the target folder in the target environment. And then we enter into the build phase, wherein these are the actual heart of the solutions, wherein the command is the idea is to use the snapshot and restore the snapshot by creating a new DB instance. So for that, we use the AWS RDS restore DB cluster from snapshot command by giving the snapshot identifier and also the VPC security group in which we would want to place this temporary DB cluster. And then this is about giving some time in order for the DB cluster to be created. And finally, once the DB cluster is created, we would start by creating a DB instance. When it comes to Amazon Aurora, first we'll have to create, restore the DB cluster, and follow to that, we'll have to create a DB instance. So again, we would wait for the DB instance to be created. And this is about giving the option, the engine, which engine we would want to create. And as we said, it is Aurora MySQL. And after giving a time for the DB instance to be created and be available, we will connect to describe the DB cluster, and then we would fetch the endpoints. So the endpoints being unique and not the one and the same as the existing database with which we took the snapshot. Let us connect to this MySQL client interactive tool against this endpoint, and let us run the DB changes over here. So we will not be disturbing the actual or original databases, as the endpoints are different. Every time we restore it with the snapshots that we generated in the RDS console. So by this way, we are able to apply the DB changes, and the DB changes files are coming from the git clone option or the S3. I will be gathering the MySQL logs here and would also be redirecting any errors to the error logs separately. And these error logs could later be grabbed or could further be analyzed for, in this case, I'm giving for error keyword and would fail the build forcefully. It could be, we can slowly enhance the solutions in order to, look into the logs further and looking for other errors based on the custom error messages that is generated, and would also be failing the build according to the reasons that we encounter in the error logs. And follow to this, we could run the application test cases if applicable as per your use case. And coming to the post-build section, now though we have a clear solutions of having a temporary cluster created, a temporary DB created under that cluster, and finally we have applied the DB changes, and then we have checked for any errors, and if it's all successful, it will be progressing, or else we will be failing the build, and thus the solution is complete here. And then coming to the post-build section, let us not leave the databases and the clusters as is, and let us drop it as we have created only for temporary testing purposes. So we come here and use the RDS delete statements in order to delete the instance and delete the cluster. So with this, we have a complete working solution which is implementing the CI/CD for databases. This is the gist and the basic idea of implementing CI/CD. And this could be further, and there is a lot of room for improvements. We could even generate reports and generate artifacts on output files based on the changes that we apply. But this is the basic idea of how do we go ahead and implement it by utilizing all the features and the vital features of RDS, how we go ahead and implement the solution using the native tools. So with all that being done, let's see how notifications are generated. Coming from the build perspective, in case of a code pipeline execution is starting, then we are notified from our with the details and with the pipeline's name in the Slack channel that we have configured. This is an example of a stage that has failed, and also a stage about apply final, and there is another code build test that has actually failed. Let us discuss about, so all that we have seen the ideas and the notifications about implementing. Let's see the alternate idea about, seeing the solutions work. So instead of going with all the service, using of all the services and complicating, to start with, I encourage and insist people who are watching this to go ahead and try out with a simple S3 bucket. Just start by creating with a text file or a SQL file with a couple of alter tables and a create table statements, place it into the S3 bucket of your respective account, and then go ahead and create a code build service as a project, and then copy this into your managed images or your custom images if you would like to use the ECR. And then using the CLI, create a simple RDS DB and then take a snapshot of it and try implementing the solutions. If not, and then a tag one by one, you can add all the other services as and when you could make progress from each of these stages. Then it should be definitely successful, and you should be able to see a working solutions over there. And then follow to that, you could do the build and notifications for you. Hope this is very interesting, and also like encouraging you to go ahead and try some new solutions. So thank you so much. Thanks for watching. If you're interested in more and you would like to grow along with the community by knowing from each other, please join us in the Facebook and the Twitter handles as given here. Thank you so much.
Thank you, Vijaya. Sorry for the technical issues in playing the pre-recorded video. Thank you for being available for QA. Now, let's have a quick look whether we have any questions.
Thank you.
We have a few questions from our community.
Sure.
I will ask one by one. And
Sure.
the first question is, we would like to know about your scholarship and re-event in experience in 2019.
Okay. Before applying, I applied for the scholarship as part of the vPowerTech grant program initiative, which was started by AWS. And even before that, I was writing and blogging for AWS in my very own blog and in LinkedIn page as well, and was also part of the community AWS here in Bangalore and also in Chennai. So by that way, I was growing. And finally, through all these contributions and other stuff, I got selected. It was one from India. So happy for that and grateful for that as well. It was experience was very I can't even explain, unbelievable crowd, and how they managed and organized the event was amazing experience for my career as well. Thanks to AWS for that and to the community as well.
Thank you. I will go on to next question. Tell us about the toughest problem faced when architecting on AWS and how you solved it.
Even for the same use case what we have done here, there was a lot of difficulties in doing it. At least I would have come across some 100 plus run failures, but finally was able to achieve it, because it's frustrating when you continuously see failures for more than 10-20 times of builds failures. But finally take some time out, look into the problem, discuss with the community or discuss with your friends who are in likewise projects, and then we were able to achieve it. technically, I should say I refer to the, in case if I was struck technically and if I needed any help, always there are documentation. And one good thing about AWS documentation is they have a blog for each and every section, say AWS DevOps and even for AWS RDS. And many of the teams and the companies who have implemented the services like RDS do share their use cases and the outlines and guidelines for implementing the same. So I have taken a lot of referrals from those blogs as well. And also your YouTube videos, and there are a premium support FAQ pages and other things which are really helpful. I did get some input from there as well.
Thank you, Vijaya. Let me check we have any questions from the attendees end. The first question, how can we implement CI/CD pipeline for serverless architectures?
Serverless, sorry, I haven't worked before, but probably I could get it from the community and share the links for you. I have done only for the use case that I have shared now.
Okay, no problem. Next question, and I think he missed some details, and he would like to know, how do we shut down full systems while we update database? If not, how do we get the data from the all database that changed while we are restoring from a snapshot?
Obviously, when you're taking a backup, there is a maintenance window during which the backup is taken. So we have to ensure, though the transaction logs are captured, we have to ensure we are not running any jobs or any updates to the database objects by that time. So that is about using the backups. Or when it comes to snapshot, a snapshot is obviously a point in time image of the database along with the data. So it's a trade-off. Either you have to agree and stay with the point in time data that will be available from the snapshot, or you go with a backup and then start restoring it. I think one difference with everybody will know is that backups are not available when the main database, RDS database, is deleted or completely crashed in some cases. But wherein if you have taken a snapshot manually, even with that point in time, it will be available and you will be able to restore and get the database based on this snapshot as well. So I think it's a trade-off that we take it. You don't have to shut down completely. There is a backup window during which the backup is taken, and also for snapshot, you have to plan accordingly and use it.
Thank you, Vijaya. We have 2 more questions from our community.
Sure.
We would like to know about your favorite service in AWS and why it is.
Favorite service, when I started, S3 was much easier because nothing else was getting into my hand. Everything was bouncing. So I have to come back and repeatedly see about other services, why code build and why code pipeline. From a DevOps, I was coming from DevOps background, so I was seeing that. But comparatively, S3 seems to be very easier. I just added my image and started using S3. I think most of the services will use S3 for their data storage, even for AI backgrounds, for analytics background. Even people using big data processing, everyone would do S3. I think that is easy, comfortable, and anyone could start with that service. So S3 would be the favorite one.
We have one more question.
Sure.
As an AWS professional, how does your day look like? And we would like to know your day-to-day activities.
Day-to-day activities, it's like taking up a business use case and start discussing. Slowly, we'll be framing the use case architecture. It doesn't happen over at least in a week or so. There will be a lot of changes. One thing that I have observed from my experience is be open to change, and also keep learning on a daily basis, if not daily basis, at least weekly basis, because on cloud, there are a lot of releases happening on a daily basis from AWS. If you could see the product page and features page of AWS. So learning everything as a whole in one shot is not possible. So I would recommend people to keep watching the space and also the blogs. If you're according to your relevant area, be it AI, or if it is big data, or if it is about compute services, just watch the space so that you grow gradually rather than breaking your head on any point in time whenever you need it. So that will be my advice. And yes, not all days are successful. Many days have failures, and some of the days are very successful.
Thank you, Vijaya. I think we have one more question from the attendees.
Sure.
Can CloudFormation would have been implemented in the database CI/CD solution you explained? I believe for creating containers in CloudFormation would have been good option. Please give your inputs.
Yes, sure, we can use it. You can add it, and as I said in the session as well, there are a lot of improvements there, and you might as well do CloudFormation for creating easier images. Yes.
Thank you, Vijay. Thank you, Vijay, for the wonderful insight. I hope all of you enjoyed the sessions as well. If there is any additional questions from the attendees, Vijaya, we will pass it to you. Please
Sure,
log
I'll
in.
be happy to answer. Thank you.
Please log into YouTube as well, and you can comment there. Thank you.
Sure. Thank you.
Don't forget to share your feedbacks via Lanyard. Let's dive into our last technical session for today. Let me introduce Vijay Sagar Vinnakota and Arpit Malani from Amagi Media Labs. Amagi is running their platform in AWS infrastructure. This is going to be a success story on how they set up their platform. Let us learn from their experience. Vijay and Arpit will be walking us through their experience in setting up linear TV broadcast layout and on-demand disaster recovery. Welcome, Vijay and Arpit, to AWS Community Day. Over to you.
Thank you. Arpit, are you able to hear me?
Yeah, I can hear you, Sagar.
Okay. It is a great opportunity and a privilege to be meeting all of you AWS community guys out there. And Arpit and myself, we are at Amagi Media Labs, India, and we work with the cloud engineering team. We would like to take you today through some of the linear television broadcast playout on-demand disaster recovery strategies that we employ. I will first give some introduction to the topic, and then Arpit will take you through the technology behind it. Yes. What are we solving? How are we going to leverage the AWS offerings, and how are we going to do it? And finally, what kind of conclusions and future work would we be looking at? Is the agenda for today. Yeah. So first, we will go into some of the problem insights. The television that we see day to day in our homes, the idiot boxes, so-called, that we call, actually is quite intelligent because there's a ton of technology behind it. You might have seen some of these large video wall-based monitoring and control rooms, NOCs, at various places in your careers, and what's happening behind the scenes. If you look at it, there is something called a entire managed broadcast media technology platform, right? Amagi offers a entire managed service on the AWS cloud as a next-gen media tech platform. The entire platform is built on top of the underlying cloud automation platform, and it goes all the way up to managed services with an intermediate broadcast chain, what we call, where content is ingested, it goes through processing, it gets played out, and gets distributed at scale, right, over multiple mechanisms. It could be CDNs, it could be satellites, it could be fiber, right? And lastly, the content that is played out by our customers, who are large broadcasters, it needs to be monetized, right? So this entire chain is offered as a managed SaaS platform by Amagi on AWS Cloud. And today's topic is to see how, as engineers, how as architects, enterprise architects, can we keep this, a system as complex as this, immune from disasters when they strike. So a couple of minutes on what do we mean by reliability, right? You would have seen various services you would have used in your at your work, at home, where there would be a service level agreement which says, hey, I offer, let us say, 5 nines, 99.999% of uptime, which translates to less than 30 seconds of downtime per month, right? That's a hard constraint that as engineers we have to live with when we say that our service meets certain SLA, right? Next slide. Let us look at some of the AWS services that we are all familiar with. Let us take S3, RDS. These are all, they come with certain SLAs. Availability, for example, it is slightly different from the SLA that S3 is giving. S3 offers an 11 nines availability. Then EC2 offers 4 nines availability, and so on. And on top of such a generic cloud platform, all of us are building applications for various domains we work in. And the challenge is, how do you take such a system and build something that offers a high reliability, right? For example, here we have given a toy example where there is some storage which is tiered between Glacier and S3, and it is cached on EBS inside an availability zone, which is being used by certain EC2 instances. In the previous slide, you would have seen that they are all 4 nines reliability. And if you just do some high school math, you would notice that the reliability comes to 99.96, or the availability falls from 4 nines to 3 nines. Next slide. So what can we do? We can compose these modules slightly differently and bring in additional redundancy. It could be multiple regions, it could be multiple availability zones, depending on the appetite that the business has in terms of cost, right? And then suddenly you'll notice that when we compose these as systems which are deployed separately, the reliability suddenly improves. Again, you get 6 nines, right? Yeah. Obviously, nothing is free. You will notice that there is a non-linear relation between reliability and cost. To achieve from 2 nines to 3 nines to 4 nines, the cost increases in an unexpected fashion, because you will notice that other elements enter into the architectural consideration. Here, the same dual region deployment that you have seen a couple of slides back, you will notice that the blue lines that are going between the 2 regions indicate inter-region data transfer costs, which were completely non-existent if you were deployed in a single region, or 2 regions which were completely running disconnectedly. However, in this case, we want to make sure that data is truly replicating between 2 regions. and hence you get these additional costs. You can imagine if you add another region and you would like to have all 3 regions connected with each other in a star topology, then the cost will go up non-linearly. And that is the idea of reliability coming at a cost. Now, with that reliability as a requirement into your architecture, how do you manage and how do you cope with disasters, which could be small, big, human-induced, natural, malicious, right? It could be simple technical errors which could take out an entire, let us say somebody has done an upgrade to a service which is suddenly resulting in an outage of an entire service. This we have seen in various public cloud providers. We have seen within our own systems where upgrades could go wrong, right? Or it could be a hack, it could be a DDoS attack, whatever. All of these are disasters that as engineers, as architects, we need to be able to cope with and design systems against. So specifically coming to Amagi's line of business, where our customers are large broadcast enterprise networks, right? Broadcast networks. The question would be, hey, why does Amagi care about a television when there is a disaster? While it is true that entertainment is a good psychological support amidst gloom, what is even more interesting is that there are other considerations for which you'll need television in a disaster situation. It could be weather alerts, it could be government advisories, it could be law and order announcements, it could be traffic updates. Let us say there is a Californian fire outbreak, and then suddenly the fire department would like to issue advisories to the people who are traveling, right? So television and of course the other counterpart, radio, both of these public broadcast mechanisms are extremely important for disaster management, and hence television has to be available. So Arpit, my co-speaker and colleague, he will take you through some of the strategies that Amagi, and this is a very general industry approach to managing disasters, where you have hot standby, you have warm standby, and cold standby as 3 prominent disaster strategies, recovery strategies. And all of them come with varying costs and varying solution complexities. As engineers, we should be aware of what those are. We will try to present some of those challenges and some of those aspects which you can reflect upon and build something of your interest. And lastly, we should not forget that not having a disaster recovery strategy is also a strategy. If, let us say, a service that you are building is non-essential and can sustain a prolonged period of outage, right? Some considerations before we move on to the details. Are you going to have your disaster recovery on-prem or on cloud? Are you going to have true geographical network and power source separations? And would you do 1:1? That is, for every system that you have, will you have a standby system? Or for every system that you build, will you have multiple standbys, 1:n? Or would you try to do something in between as an optimization where for M of your subsystems, you will have n standbys, right? The idea being you can do better cost-effective designs when M is less than n, which is far less than 2m, right? That is the kind of approach that Arpit will take you through in the coming slides. Over to you, Arpit.
Thank you, Sagar. Thank you, everyone, for joining us today. So let's do a deeper dive into how are we solving the reliability challenges. So if you talk about any DR strategy, the first thing that would come into our mind is the downtime. So if you want a strategy with no downtime or minimum downtime, typically we recommend to have a warm standby. In most of the DR solutions, cloud turns out to be a very good option because you don't have to commit to a strategy right away, and these strategies keeps on changing over a period of time. You don't have to do a commitment. You don't have to buy hardware. You don't have to commit to a real estate. So cloud offers a very good flexible strategies in case of DR. In our case, we have a variety of customers, and I will take you through very varied use cases that we have. So we have some of the biggest broadcasters in the world, and on the other hand, we also have new age streaming TV customers which have evolved from cloud. They are into OTT, linear transmissions, and they have always been on cloud. They have never had bought a single hardware in their life. And all of them obviously will have a varied SLA requirements. So having a one single DR strategy won't be a good idea for us, because that won't fit all our customers. For us, that would be for an enterprise customers, either that could be too low for them, or for streaming TV customers, it could be too high for them. That's why over next few slides, we will try to cover how we are trying to tackle these different dependencies in the architecture. So this is a very typical common DR pattern that we have, where identical channels is being played out into 2 or more availability zones, depending on what is the requirement. Let me just walk you through the overall block diagram. Typically in broadcasting, the entire broadcasting workflows are quite intensive on the storage. So raw mezzanine files are stored. So any of the videos that you see, any of the episodic content, or any of the movies that you see, usually they range from few GBs to hundreds of GBs, because they are raw content that is being kept there. It is quite common for an enterprise customers to have the entire media library that they have, because they've been building it over so many years. Typically, this could be in terms of petabytes. So moving that component in a storage tier that suits your economically, that suits you most, and that makes most of the sense, in itself is a challenging proposition. So for example, just to keep an overall check on the storage, we constantly move across our content from S3 to Glacier, and Glacier to S3 based on the access pattern that is there. We use EBS volume. So EBS volume for a lower latencies, because as we all know, S3's latencies can vary at times. So we use EBS volume as an L1 cache, where we cache the subset of the entire media library that we have. So usually these are the media library, the content that has to go on air in next few hours. And as part of our EKS cluster and all those things that we have deployed, the output that you see, the EC2 output that you see, is a broadcast grade high resolution output that is there. And usually this whole bitrate, that high bitrate that I mentioned, these are the broadcast grade streams. We either deliver it to teleport or fiber or satellite uplinking stations. For our enterprise customers. For our streaming TV customers, we actually feed it to something like Amazon's AWS Media Live, or we generate a multi-bitrate HLS or dash out of these, and then we deliver to platforms like Apple TV. Samsung have its own TV Plus platform, Roku, Zumo, YouTube TV. In some cases, even say now Amazon Prime is coming up with a streaming TV service. Twitch. So all of them would be come under the streaming TV customers. Additionally, what we have built is a cloud-based hitless switcher. So the streams, the high bitrate stream that I talked about just now, that stream comes out from 2 different availability zones, and we have to do a hitless switching, where the end user should not be able to come to know about the switching that has happened from a region to another region. So we typically buffer for few frames, so that the switching is quite hitless. You can consider this switching very similar to what we have in case of our RDS and all. So RDS has a cluster endpoint, where based on the health of the cluster, it can seamlessly switch. The only difference is there can be few seconds of failover delay that can happen. In our case, even those few seconds is not tolerable for the end customer. So that's what we have built, and this hitless switcher can be deployed either on cloud or it can be deployed on prem. Now coming to for our enterprise customer, as I previously mentioned, so their SLAs are even higher what we can offer by with 1:n by using 2 or more availability zones. So in these cases, what we have is we have multiple standby across different regions. So how we are achieving that? So this is the entire deployment that you see there, what you have seen in 1:n, very similar deployment, but this has been spread across 2 different regions. Each region in itself is a multi-AZ deployment, and we usually deliver these streams because of the sheer SLAs. We deliver these streams over AWS Direct Connect, that also in an active mode. So how in case of multi-region we deploy it, I'm not sure if you guys are able to read it. The first region that you see on the left hand side is the US East one, and the right hand side that you see is EU West one. So the handoff how we do for a delivery is typically through Direct Connect, and the first region will do a handoff in US, the other region will do a handoff in Europe, so that there are 2 delivery paths which are completely redundant to each other. That's how we are going to deliver it. Sagar has already mentioned some of the challenges that happens when you increase the number of replicas, right? That's a non-linear increase in overall budget that is there, right? To keep a check on overall budget, we have come up with a slightly different approach that can provide similar reliability for few minutes. Obviously, nothing can beat 1:n hot standby replicas, but the amount of money that we are spending also increase non-linearly. So keeping that in mind, we have come up with a significant amount of saving, a different approach, which is M:n hot standby. So what we have done is we have split our playout server into a lightweight multi-tenant delivery servers that can be deployed across multiple availability zones. By doing this, what we have done is, so you can have your deployment server already deployed, and there is a S3 based buffer that we have built so that internally we can cache the content that delivery servers can utilize and do a playout. So most of things will remain same. So now next, moving on, what will happen in case of a disaster? So let's take in this example, say the playout 3 actually goes down. It could be because of the AZ failure, or it could be because the instance failure that can happen, right? It could be one of those 2 options. So now if you see the buffer, the channel 3 that you are seeing, the buffer have been started consumed. Because it's continuously being consumed by a delivery server. So you can see that the buffer is being depleted right now by the deployment server, by the delivery servers. So now in the meantime, the infrastructure monitoring module will bring up the playout server either in the same AZ if this was an instance level failure, or if it was a AZ level failure, then the entire the server can be brought up in a different AZ. So that's what essentially we are trying to do. By doing this, you can see that we have reduced the number of active components that needs to be there by mitigating the actual blackout that can happen on channel. And in the meantime, we have bought some time. So for next few minutes, we will be able to bring up the entire infrastructure again. Now, coming on to what specific AWS offerings are we using? And we're using a host of services. Last time I checked, I think we're using more than 60 services. So some of them I will try to put in the different pillars that we have internally in Amagi. So for ingest and storage, you can see we are using AWS S3 and Glacier. For the entire media library of the customers. And what is this media library? So media library typically consists of video, audio, subtitles, meta, schedule. So why do we need so many video, audios, and subtitles? So typically in Europe, if you see, it's a quite diverse continent, right? They have a lot of audio languages. So in few of our customers, we have seen as high as some 16, 18 different audio tracks that are attached to videos. Similarly, those many subtitles can also be there. for media processing workflow, because these content arrive from various variety of sources. So we have built our own QC and transcoding service that we have built on top of the AWS batch instances. At any point of time, and we leverage Spot instances quite exhaustively. So at any point of time, we use roughly around, say, a few thousand cores in our infra that is entirely running on Spot instances. And we also have a fallback onto on-demand instance. So in case if there is sudden surge in Spot instances, we always have a fallback to on-demand instances also. In some cases, we also use AWS Media Convert for our transcoding service. For our playouts, primarily built on top of Kubernetes. So we use EKS and EC2 instances. For our lot of our custom workflows that we have built over time during the entire playout management that you see here, primarily AWS Lambda powers most of them. For our content delivery, either to, say, cable or satellite or WAD that you see, we use AWS Direct Connect because it provides the reliability that we want for our enterprise customers. For our streaming TV customers, we use AWS Media Live and the entire Elemental workflow, so Media Live and then Media Store and the CloudFront for a final delivery to an end as a CDN. Apart from these services, we used a host of other AWS services that would range from logging to security to media services to analytics to machine learning. So yeah, it's difficult to capture all of them here in one slide. Okay, in this slide, what we would like to cover is AWS. Obviously, whatever AWS has made it incredibly easy for us to have different strategies, different DR strategies, to come up with different DR strategies for variety of our customers. But the biggest advantage that we see right now is that any new service that comes onto AWS or even the existing services, if we are thinking to use it, reliability, redundancy comes out of the box itself. So either it's multi-AZ or multi-region, that's by default, that's baked into the service itself. So that's a very good starting point for us. S3 scalability and reliability. So Sagar has already mentioned, so S3 has some 11 nines of reliability and 4 nines of say availability. That itself is quite unmatched. I mean, even if we look into any other services that will be offered. What we have struggled a bit is for the CRR, which is a cross region replications. So we have built our own layer on top of the existing one, so that we can get seamless and transparent access to our content. DynamoDB Global Table helps a lot in reducing the latencies. Similarly, RDS, global read replicas and global databases. We use media live pipelines and media workflow quite exhaustively. Similarly, we use active connections in Direct Connect. So for our delivery, I've already mentioned. So that also is something quite nice. And just a word of caution for the entire community that obviously AWS makes it incredibly easy to achieve all of these things, but we also have to do our part, where for your use case, for your specific use case, you might have to come up with the approach which is cost effective and basically meets your SLAs, because at times if you don't plan it upfront, it can become either quite costly or you'll not be able to achieve the desired SLAs that are required. And AWS has very good community. You can go to their blogs. They have patterns, anti-patterns, all of them already published on their website. That's a very good place to start with. Yeah, for next section, I would like to invite Sagar back again. Sagar, over to you.
Thanks, Arpit. So we would like to conclude on what we have tried to rush through in the past few minutes on what DR strategies are. It's a complex topic, but we will also try to give you some hints on which way we are going and which way we think the industry is going on the cloud, right? With all of us engineers and architects, we are living in an era where truly it's 24/7. The cloud doesn't sleep. Our services don't sleep, right? And hence blackouts have become a big issue, right? And while your service might fail because you have a DR strategy, your DR itself cannot fail, right? So that's what Arpit was trying to mention, that, hey, you need to have the design rock solid. And then cost versus reliability. Again, Arpit has highlighted this, that there are all kinds of use cases. High-end customers would want reliability at any cost because their businesses are multi-billion-dollar businesses riding on top of some of the solutions that we give, right? And then the low-end might say that they will trade off a little bit. And the spectrum is wide, and solutions also have to be like that. Then similarly, customers' needs might be, they want probably a very entirely automated system where there is no interference of either Amagi's DevOps or the customer's DevOps. Everything should happen very transparently. Switch over, failover, and then recovery. Everything happens, right? To that, from there to somebody might want a fine-grained control on which region is going to go on air next, which channel is going to play out from which region or which availability zone. Somebody might want those kind of fine-grained controls, right? And if you look at it, all of this has to be done at scale. It's not sufficient that you do it for one channel or a group of channels or one customer, right? This has to be done at scale, reliably, consistently, day in and day out. And the thing is, unless you have solid game days or some such processes, you cannot expect that the strategy will work out by itself when a disaster happens, right? So you need to have simulations, you need to have practices in-house to get there and be ready for a disaster for your particular solution or your product that is deployed on AWS, right? Or any public cloud. Yeah. So, Arpit. Yeah, so we are looking at multi-region failovers with distributed state management being a very hard problem, right? And it's been made harder, as Arpit was pointing out in an earlier slide. For example, S3, Dynamo, these are all eventual consistency models. And when you distribute state across multiple regions, either through replication inbuilt or your own custom replication mechanisms, it becomes a very hard problem, right? As someone was saying, the first rule of distributed systems is don't distribute. But then we have to distribute for our survival, right? When you do that, you need to have strong mechanisms. And lastly, dynamic on-demand MS-chain architectures is where Amagi is innovating heavily, both for our customers' benefits as well as to ensure that the latencies of bringing on a standby system is to an absolute minimum timeline, right? Some of these challenges we are actively solving. We would like to engage with the community anytime any of you think the community thinks they have something interesting to share with us publicly. You're very welcome to contact us out at Amagi. You can go to our website and you can just post it to us, and then we can get back. Okay. Yeah. So thank you very much. Thanks, Arpit, for joining me today.
Thank you, Vijay and Arpit. Now let's have a quick look whether we have any questions from the audience.
Sure.
And the first question is, if there is an outage in case of OTT platforms, how do these systems manage to retrieve session tokens after the recovery? Why do they not ask for authentication or for a new session after the recovery?
If there is an outage in the case of OTT platforms, okay. So I'll give a short answer, and Arpit can chime in. So you're talking about the application, OTT application, right? Let us say your favorite streaming television app. It has a browser application or some inbuilt application, and let us say that has some cookie-based authentication token-based mechanism, and it is either backed by a CDN or it's usually it will be backed by a CDN, right? And then that is where the handoff happens, and session management is handed off there. So you're independent of how your actual delivery, video delivery mechanisms happen, right? The state management happens in a different layer, which is by itself available. For example, you could do cross-region ELBs, or you could do CDN-based session tokens, right? Arpit, what do you think?
Correct, Sagar. So you're right. So the first part is the authentication part, and even we have to give some credit to even the HLS architecture itself, where the HLS architecture by nature itself retries both in your application also where you are retrying. So if there was a downtime in the overall, say, in the stream itself, the moment it connects back and the stream is available, the HLS by nature itself will connect it back.
Thank you, Vijay and Arpit, for the wonderful insight. I hope all you enjoyed the sessions as well. If there is any additional questions from the attendees, Vijay and Arpit, we will pass it to you.
Sure.
Please log into YouTube and you can directly comment there as well. Thank you.
Sure. Thank you.
Thank you so much.
Thank you, everybody.
Thanks.
Bye.
We are winding up track 02, requesting all of you to join track 1 for closing notes. We will also announce the quiz winners during the closing note. Now, I would like to take this moment to thank all our speakers who shared and enlightened us with their experience and their journey on AWS. It was definitely a huge takeaway for all of us. And let's have a small round of virtual ovation for them. Last but not the least, I would like to thank and appreciate all our attendees for making this an amazing event. Thank you all.